Good morning to the all the participants. We will start by 10 minutes.
A very good morning to all of you, dear participants. Uh, we are conducting this 6 days short-term training program sponsored by AICTE on plastic waste management through waste to wealth concept. We are conducting this program on offline and online mode. We have faculties, students across the country. So I, on behalf of CIPET, welcome all of you, and I invite Principal of Central Institute of Petrochemicals Engineering and Technology, Guwahati, Dr. Horekrishna Dekka sir, to give his welcome speech and talk on the CPET activity. So I invite sir, over to sir.
A very good morning to all, respected all the participants for this short-term training program sponsored by AICTE. The title of the program, as already our coordinator has told, the coming 6 days we will be discussing on various issues, topics, subjects on plastic waste management through waste to wealth concept. Uh, from the CIPET team, on behalf of CIPET team as well as on my behalf, we sincerely acknowledge and thanks to AICT for giving financial support to conduct this 6 days short-term training program. In brief, in these 6 days, we'll be discussing on plastic waste management, single-use plastic and waste management, then different kind of advanced manufacturing process for plastic products, the biodegradable, the bioplastics, then plastic product manufacturing, and especially the recycling techniques and related to entrepreneurship aspect. Details on the different biodegradable products which are already exist in the market. So all these issues will be covered during this 6 days short-term training program. We, as already you may be knowing, like around 400 participants across the country has participated in this short-term training program. And I wish all the participants all the best for this short-term training program. And I expect at the same time that the active participation from the participants would lead to a fruitful conclusion of this program. I'd like to take this opportunity to uh, use this forum to explain the different activities of CIPET, because we believe this short-term training program will also lead to a avenue so that we can understand better each other, and which will result the collaborative research work, collaborative different academic activities in future. And with that hope, I would like to explain few of our activities that we are expert in this core field of plastic technology and other facilities available at CIPET. Yeah, the main objective of CIPET is to provide qualified professionals at various skill level. It starts from level 1 to level 10 of NSQF through different academic like long-term programs, short-term programs, skill development and entrepreneurship development program in the area of petrochemicals. Especially emphasis was given on the plastic sectors. We are also providing technology support service as well as consultancy services in the area of design, tool room, CAD/CAM and CAE, plastic processing, testing and quality assurance, as well as inspection services, third-party inspection services, and calibration of different equipments associated with petrochemical industries, including plastic industry. To undertake research and application development in the petrochemical sectors, including plastics, synthetic rubber, textiles, fertilizer, pharmaceuticals, additives and coatings, etc. Another objectives of CIPET is to enhance the professional skill and competency level of faculty by providing an opportunity for faculty to upgrade their qualification and technical expertise through advanced training programs. So this is one of such training program which is supported and funded by AICTE, where we are trying to enhance the professional skill for like how we manage the plastic waste, how we do the recycling of plastics, etc. So if we go back to the history of CIPET, CIPET was known as Central Institute of Plastics Engineering and Tools, which was established in 1968 at Chennai, which was set up by Government of India under UNDP assistance. The main objective at that time was only limited to plastic engineering as well as tools. And during this period of time, we have expanded our working horizon, and today we have a pan-India existence of around 42 centers, and we can say like almost every state we have one CIPET centers. Depending on our core activities we conduct at CIPET, we divide this institute in basically three categories. The first category we call IPT, Institute of Petrochemical Technology, where the conventional, besides the conventional courses, we are also running like BTech, MTech, those advanced courses. Second category is called CSTS, Center for Skilling and Technical Support, where we conduct the short-term as well as long-term training programs. And these long-term training programs is the level of like diploma, post-diploma, etc. Then third category is SARP, School for Advanced Research in Petrochemicals, where we focus and restrict our studies on research and development activities in the field of polymer science and technology. So in SARP, we are conducting only PhD programs, and basically in the field of polymer science and technology, material science and engineering, plastics engineering and technology, mechanical and material engineering, chemical engineering, etc. in in collaboration with different universities. We have three such centers, one at Chennai, another is at Bhubaneswar, and third one is at Bengaluru, where the intensive research program we are conducting on these topics. We also have foreign collaborations such as like University of Toronto, University of Guelph, Durban University of Technology, etc., where we are conducting, we are developing new products, new technology in this field. And as you know, like in NSQF level, this scale is maintained as considered as level of 10. Instead of petrochemicals technology, we have 8 centers all over India: Ahmedabad, Bhubaneswar, Chennai, Kochi, Lucknow, Raipur, Murthal, and Jaipur, where we are conducting BTech programs, BTech in plastic engineering, BTech in manufacturing engineering, MTech programs, MTech in plastic engineering, MTech in polymer nanotechnology, ME in CAD-CAM, integrated MSc Tech, a specialized MSc on biopolymer science and technology, and our regular MSc in polymer science. And these all courses are at the level of NSQF level of 8 to 9. Then the third category of our CIPET centers, the CSTS, Center for Skilling and Technical Support. We have around 29 centers throughout the India. In the map, in the Indian map, the centers where it is located is shown. And basically we conduct postgraduate diploma, like postgraduate diploma in plastic processing and testing, post diploma in plastic mold design and technology, and diploma in plastic mold technology and diploma in plastic technology. These courses we are conducting in these CSTS centers, and the NSQF level is for these courses are from level of 5 to level of 7. Now, CIPET is a kind of unique institute because we produced manpower, we train manpower according to the industry's need. And our students are trained in such a way that they are directly fitting in the industries, especially in the field of polymer industries. Till date, we have produced around 3,13,029 number of trainees through our different long-term and short-term training programs. And Government of India has given a task to produce another 1,20,000 students, trainees in different academic courses for the year of 2023 to 24. And a brief diagram was shown here how per year we are producing students, mainly which these students they are going for different industries. As I already mentioned, like CIPET is a kind of unique institute. We are also providing technology support service besides our academic courses to the industries. For that, our activities is recognized by different standards, such as our testing laboratories are accredited by NABL. Our pre-delivery inspections are accredited by NABCB. Our testing laboratories are also accredited, recognized by BIS, Bureau of Indian Standard. Our academic activities are under ISO 9001 certificate. Now, similarly, for technology support service also, we are till like in up to 2021, we have provided around 3,95,483 numbers of support to different industries, not only in India, even in different abroad countries also, we are providing technology support service from CIPET. And Government of India has given a target to give another 1,10,000 technical support services by 2023-24. Now coming to these specific centers where we are conducting this short-term training program. The CIPET CSTS-GUWAHATI, which was established in 1999 with the support of Government of India and Government of Assam. And the prime objective of this center was to produce skilled manpower for plastic industries and to support the plastic sector, plastic industries to grow up in this northeastern part of India. CIPET CSTS, as from the name itself, it reflects that it comes under CSTS category, and thereby we are offering academic courses, 2 diploma courses, diploma in plastic mold technology and diploma in plastic technology, and 1 postgraduate diploma in plastic processing and technology. I'd also like to take this opportunity to this forum to spread this message that we are the admission announcement is already going on, already opened. It's a online they can fill up the forms. It is anyone can visit our website www.cipet.gov.in, and the details about the admission process are you can get the information from the website. Besides our long-term training programs which are affiliated, which are recognized by AICTE, we are also conducting short-term training programs, skill development programs, which are sponsored by different government agencies as well as different different industries under CSR activities. We are also conducting in-plant training programs for different colleges, universities, especially engineering college students. We are also conducting industry-specific programs, entrepreneurship development programs in the field of polymer science and technology. Few courses of such are like plastic processing, machine operator, injection molding, blow molding, extrusion molding, machine operator, plastic recycling, plastic product manufacturing operator, etc. And the entry qualification for such courses are class 8 pass students, and preference was given for economically weaker section of students, which are underprivileged students. They can get the benefit from this type of short-term training programs. And the duration of such training programs varies from 3 months to 6 months. From CIPET Guwahati, every year around more than 1,500 students we train in this sector. Our effort was well recognized by Government of Assam Skill Development Mission. They have conducted one survey based on our activities, and they have offered the Gold Award for giving the best training provider among Northeast India. So this is one of the major contribution is coming from different recruiters, which are like our success is also based on their active participations with active cooperation with CIPET Guwahati. We are placing our students in different multinational and Indian companies such as Havel India Private Limited, Skipper Limited, Tata Autocom Systems, Time Technoplast, Prasad Plastic and Engineering, Godrej Consumer Products, etc. Now I'd like to share some of our success stories before you. We are the partner of ASDM for organizing World Skill competition in 3 trades, and 2 of our students they have cleared they have went up to the national level competitions in India Skill Competition 2021. They are they have participated in plastic dye engineering event, and up to the national level they have cleared. So some of the infrastructure facilities like classroom, then like other extracurriculum activities, hostels, we have separate boys hostels, girls hostels. We have digital library, conventional library. We can also access the National Digital Library from for the E section, and all the CIPET centers we are all well connected through video conferences, so that the expert talk specific lectures can attain through all the video conference systems. Now, this is one of the very important slide for you. Like for design and CAD/CAM in department, we have different softwares through which we can design tool different machines. We can design mold, and for that we have softwares like AutoCAD, SolidWorks, Unigraphics, Solidus, Roy, Mastercam, Analysis, etc. So these facilities we can also share through online method, online resources, and we have a provision of giving short-term training programs on these softwares through online. In toolroom section, we have CNC machines, different CNC machines such as CNC lathe, CNC milling, CNC EDM, CNC wire cut, etc. All are very high, very precise and highly advanced machines we have. Besides the conventional machines, we also have conventional like lathe, milling, and shaping, drilling machine, etc. We have, and our students they got the exposure. They make the different kind of mold with the help of these instruments or with the help of these machineries, CNC as well as conventional machines. In processing department, we have the stretch blow molding, extrusion blow molding, monolayer film plant, pipe extrusion plant, rotational molding, injection molding machines of different capacities, and these are the few products that we are producing at our processing workshop. Some of the specific mold that our trainees are involved in making this type of advanced mold with the existing machineries that we have in the workshops. Even we are also fabricating different machineries for different institute and different universities. And time to time, the success stories are coming in the national as well as local newspapers. Yes, the product developed by our students, as you know, like in Northeast is rich of different natural resources, especially like betel nut, then coir, then the different kind of fibers are available in the northeastern part, and our students they have made this type of composite systems which can be used as which can be used for different applications, even like structural wise or different household application it can be applied. Now, one of the technical support service is we are providing through testing. Our testing laboratory, we are conducting as per ISO ISA 17025, and we have around more than 500 test methods are recognized in basically two sector, mechanical and chemical discipline for plastic and associated products. You will be very happy to know that like uh, plywood, block board, then different composite board we are testing at CIPET CSTS Guwahati, and we are offering these services to the rest of the countries. Bureau of Indian Standard BIS we are a nodal agent for BIS in the northeastern region, and under BIS certifications we have around 34 number of products recognized at our laboratory. CIPET Guwahati Plastic Testing Laboratory is participating in many government as well as private laboratory for inter-lab comparisons, ILC, as well as proficiency test under lab recognition scheme. The different advanced machineries such as universal testing machines, uh, uh, UV tester, impact tester, rheology, atomic absorption spectroscopy, TCA, DAC, FTIR, etc. are available at CIPET CSTS Guwahati Testing Laboratory. And we are associated with different government through this providing these services through testing department. I'd like to also mention before you that CIPET is first of its kind that participated for third-party inspection in India. Currently, in different states, the Jal Jeevan missions, that scheme is going on, and CIPET are one of the third-party inspector going through different plastic industries for verifying before the procurement. Now, I'd like to focus today. I'd like to focus a center that we have specially for plastic waste management. The government of India has set up. Stop. That government of India has set up a center, first of its kind, at Guwahati. It's Plastic Waste Management Center. Sharing good. Now I'd like to show you that slide for Plastic Waste Management Center. The Plastic Waste Management Center, in short we call PWMC, it was established by Government of India in 2008 and dedicated to the nation in 2010. And this center is a model center on plastic waste management. And the main objective of this center is to train professionals especially for plastic recycling industries, and to provide technological support services, especially to the plastic recycling industries. So here I am showing you the different machineries available at PWMC. One of the study that we made in PWMC is like we have adopted one villages and near the PWMC area around 10 kilometer of radius. We have provided 3 different kind of dustbin system to each and every house in that villages. This study we made it in 2010. I'm just talking. I'm just discussing that thing like which we did in 2010. And from each and every household, we are collecting the, especially the recycled plastic waste. Here in the right hand side, I am showing you one cycle van that we have engaged people for collection from each and every household. And after collecting, we did the segregation process and we separated different plastic items like material wise, like PPE, polyethylene, polypropylene, LLDP, like separately we have segregated. And then based on the different machineries we have, we shredded it, make smaller pieces, then we make the granules from using different extrusion machines, twin screw extrusion machines, which are available at PWMC. And finally, the plastic waste that we have converted into granules, and that granules we have accordingly made different kind of products, especially like flower pots, then uh, 10 liters bin, 12 liters different bucket. Those type of products we have prepared from those plastic waste. And again, those plastic waste we have distributed to the village people. So that study, it shows that these waste, which are considered as a waste and nowadays making a lot of problem, is nothing but a wealth, because we can recycle it. And the beauty of this plastic is that we can recycle we can do the study for like the life cycle study we can do, and based on that we can go for recycle for many times. So the three different kind of system like line we have, basically we categorize it like mechanical recycling plant and chemical recycling plant. And in mechanical recycling plant, we convert the recycling waste material into granules with the help of extruder through mechanical way. And even the system that line, you can see that in that line, we can also go for your different plastic carry bags. We can go for densification of different plastic carry bag, and that can be, after densification, it can be shredded, and it can go through different cleaning process, and finally through different twin screw extruder it will be melted and different granules we can prepare. That granules again, it can be made as pipe plant. We can make different kind of pipes, as well as we can, with the existing facility that we have, we can make box trapping system. So besides this, we also have different kind of injection molding machines of different capacities we have, through which we can convert those plastic recycling granules into different products. Another way is called chemical recycling plant. The polymers which are cannot be segregated easily, or which are associated with, like say, with different cellulosic or different aluminum foils, which cannot be easily segregated from those parts. So in that case, we can go for chemical recycling plant. And in that chemical recycling plant, that the machine we have, it has the capacity of converting around 400 to 500 liters of petrol from 1 ton of plastic waste. If the quality of plastic waste is very good, then even we can convert up to 600 liters of fuel we can convert. So basically those all these facilities will be showing you, will giving you a live demonstration, especially like different process, how we fabricate different process, then what are the different in tool room section, in tool room department, how we can do the different kind of use the different CNC machineries, how we do the testing and quality control of different plastic products, and especially how we convert the plastic waste, how we do the segregation shredding system, and we go for a mill extrusion process. Those things will be trying to give you a live demonstration in during this 6 days training program. I'd also like to share one of the activities that we are conducting. We did in the field of plastic waste management centers for providing a awareness program, giving awareness to different our communities. Just I'd like actually I want to show you one videos. I could not find it now. That CIPET uh, a, has created that record of creating around a logo, recycling logo through human. All the CIPET faculty members and students, we have made a human-made recycling logo, and that message was given to So we have we have crossed 50 years, and we have celebrated Golden Jubilee in 2020 and 2018. we have completed Golden Jubilee, and during this Golden Jubilee, we have make a human made recycling logo to spread the message that not only to India, like to spread this message to all over the world that the recycling is one of the way to face the problem of this plastic pollution. So I'm extremely happy to share this video before you, so that even this message I'll please you so that you can even spread this message to your different institute for plastic recycling. Reduce, reuse, and recycling. Save water, save future. This logo was created by more than 3,000 of students and faculty members of CIPET, recorded in the Asia Book of Records. So this is all about like the different activities that we are already into this line, and even we have adopted many schools for giving awareness on this plastic waste, how we can go for plastic recycling, reuse, reduce concept. Even we are also working on 5R system. We'll be discussing these things in the different lectures. So I think I believe that different expert lectures will be focusing on this on plastic waste will definitely will be helpful for you, and will be getting a new taste of on the subject of like plastic waste management, and how through this waste we can convert to wealth. It can be discussed during these 6 days long short-term training programs. So with these few words, I am concluding my inaugural speech, as well as the role of CIPET for the growth of polymer industries. Thank you very much. Thank you very much all for your kind attention.
Thank you, Dr. Horekrishna Dekke, sir, for your valuable presentation on the activities of CIPET. Indeed, it's really a very good informative session where we have come to know that CIPET is such an organization which is bridging the gap between the industry and the academia. In this era of polymer, CIPET is a true friend for this plastic fraternity, and we believe that in future also CIPET will contribute for the growth of this polymer industries. Apart from this one of the major issues now we are facing is plastic recycling. So, in line with this today's session and this program, which will continue for 6 days. So, we hope we will get many informations which will help how to address the issues, different issues of plastic waste management, which has become now an environmental issues. So now I invite Dr. Jutika Devi to brief about the program, and resource persons as well, who will be addressing different issues of recycling in the coming 6 days. Over to Dr. Jutika.
Thank you, sir. So, as all of us know that plastic waste management through waste to wealth concept, the title of the program. This is a program sponsored by AICTE with an objective to plan and help in imparting quality technical education in the country and to support technical institutions in fostering research, innovation, and entrepreneurship through training in various emerging areas. And we expect that this course will help and enable faculty members, research scholars, and students in the field of technical education to introspect and learn techniques that can help prepare students for active and successful participation in the knowledge society. And during this all the 6 days, we have lectures from various speakers from different organizations along with hands-on demonstrations. So Professor Abhijit Bandopadhyay, Kolkata University, Dr. Pradeep Paik, Indian Institute of Technology, BHU, Professor Niranjan Karak, Tezpur University, K.A. Rajesh, CIPET IPT Kochi, Ambika Joshi from CIPET IPT Raipur, Praveen Vibasham from CIPET CSTS Ranchi, Dr. Smita Mohanty, CIPET SARP LARPM, Odisha, Professor Bimal Katyar from Indian Institute of Technology, Guwahati, Sandeep Samanta from Star Cement, and Dr. Nirmala Devi from Dorna International Institute of Research will be the speakers, along with Dr. Hare Krishna Deka from CIPET CSTS-GUWAHATI and Dr. Jutika Devi from CIPET CSTS-GUWAHATI. And we are happy that almost more than 350 numbers of faculty, scientists, engineers, researchers, postgraduate students, engineering students, along with industry participants are attending the event, and we hope that it will be a successful one. And now I request Rotikanta Das sir for giving the presentation.
Thank you, Dr. Jutika. We have come to the end of this inauguration session. So, I would like to thank you, AICTE, for sponsoring such a very valuable program for us, which will enlighten definitely many issues will be discussed during these sessions. I would like to thank all the research person who has given their consent in spite of their busy schedule to address the sessions, which will is there. We will be having 3 sessions. So we will be having very experienced and learned research person as Dr. Jutika has explained. So we'll hope we'll have a fantastic session, and thank you very much all the participants across the country who has given their time and concentrated on this seminar. This is a national seminar. In fact, it was initially a offline program, but during this year we have conducted 6 programs. This is the last one in this year, sponsored by All India Council of Technical Education. And what we have learned from the last 5 programs, that many participants have shown their interest and they are interested to join this program from different parts of the country. So with due permission from AICTE, we have made it a blended mode. This is offline and online. In offline mode, today we have around 50 participants from different engineering colleges, faculty members from the different engineering colleges, universities, and students from different engineering and science colleges. So I welcome all of you for this session, and we hope that we'll have a very good session in the coming time. So with this, I'd like to request Dr. Jutika to carry forward the further programs, and with this, the inauguration session is concluded here. Thank you very much. We will meet again at 11:30 a.m. with the speech by Professor Abhijit Bandyopadhyay from Calcutta University, very experienced and learned professional, and he will discuss about the various issues of plastic waste management. So thank you very much. We will meet again at 11:30 a.m. Thank you. Thank you very much. 11:30 itu off করে দিয়া off করিস
kalau যদি বাইরে যোৱা যায় গৈ স্কুল আহি কিনে 11:30 টাইম
একটু কনফার্ম করে দাও
Thank you very much. Now we have the tea break. So after tea break, we will meet again, and you can be at the same line or you can rejoin again at 11:30. Thank you so much. Good morning, sir.
Good morning.
Yes, sir. So we are starting by 11:50.
Okay, no problem. I'm ready.
Yes, sir. A very warm good morning to all of my dear participants. We have with us Professor Abhijit Bandyopadhyay sir from Calcutta University. Sir will deliver a talk on about plastics and its recycling with special reference to circular economy. So before proceeding to sir's lecture, I just want to briefly introduce sir. Am I audible? Dear participants, am I audible to all of you?
Yes.
Thank you. So before starting the session, I would very briefly like to introduce Professor Abhijit Bandyopadhyay sir among all of us. So Professor Abhijit Bandyopadhyay is the Professor of Department of Polymer Science and Technology, University of Calcutta, and he is the Technical Director of South Asia Rubber and Polymers Park, West Bengal. Sir's area of expertise is not limited to hyperbranch polymers for industrial and bio applications, photophysical properties of polymers, polymer nanocomposites, polymer blends and composites, polymer 3D printing. And Sir has vast experience of more than 20 years related to the polymer science and technology. Apart from the academic recognition, Sir had many professional recognitions also, and he has received many awards from different national and international bodies. Among them, he is the recipient of Young Scientist 2005 Award from Material Research Society of India, Calcutta chapter. He is the recipient of Career Award for Young Teachers from All India Council for Technical Education, Government of India in the year 2010. He has the memberships and he is a recipient of fellowship of different international and national bodies. He is the elected fellow of International Congress of Environmental Research India. He is the life member of Society for Polymer Science India. He is the life member of Indian Rubber Institute. He is the associate member of Indian Institute of Chemical Engineers. And he has the vast expertise for providing industrial consultancy, just like for analysis of battery separator and compounds for Exide Industries Limited, analysis of carbon black samples using DLS and TAM for Philips Carbon Black Limited, then for development of coal strengthening compound for blast furnace operation for Plastochem India Limited. He had national and international collaboration like CSIR Pretoria, South Africa, Astomar Division, IPF Durston, IIT ISM Dhanbad, IIT Kharagpur. So we are very privileged to have Sir, who has more than 200 number of publications of national and international reputes. So we welcome Sir.
Thank you, Dr.
Over to you,
Juthika.
sir. Yes, sir. Thank you.
Thank you, Dr. Juthika, for this invitation, and good morning to all of you. Can you hear me? Please, someone confirm.
Yes, sir. Audible, sir.
Okay, great. So, thank you once again for the invitation, and good morning to all of you. Today, I'm going to speak in very general terms about plastics, its recycling in special reference to what we are nowadays debating about is the circular economy. Now, plastics, I think all of you are aware of this material, but I would like to present this material in a different way, that plastics is basically is not a new material. In fact, plastic is a state that actually we describe about a material. That is, a material which remains in a plastic state is called a plastic. Not necessarily it has to be a polymer, which is our subject of discussion today. But some other materials can also remain in the plastic form, means that the material which shows a plastic deformation. So this is the first time we say that we have a material which is not being named by its, different class, rather it is named by a generalized state, but we call it as a plastic state. Now, as I mentioned, that this plastic form or this plastic state you can achieve by having a polymeric material. Now, this polymeric material is a different kind of material altogether from all other earthly materials, by virtue of the fact that we describe this material of having Deborah number greater than 1. Now let me tell you what is Deborah number. Deborah number is a dimensionless number. Dimensionless numbers are frequently used in engineering. I think most of you are aware of. It's a group of numbers, or group of parameters rather, group of parameters having no dimension, and sometimes we combine many odd parameters together to get a zero dimension, and these sort of dimensionless parameters are very easily being fitted into some expressions to give a new implication of that expression. So we have many dimensionless numbers being used in both polymer and chemical engineering. So very important, and the very I would say your significant dimensionless number in polymer engineering is the Deborah number, which actually characterizes the material for high polymer material. Now, Deborah number is the ratio of relaxation time to that of the observation time, means the time through which any sort of stress is being applied on a material, and relaxation time is that the time to dissipate that stress. So it is the ratio of that relaxation time and your observation time of that stress application. And for polymeric material, you have the de Boer number greater than 1, and this is the speciality of this material. That is what we call it as a delayed responding material. Now, this material in a specialized state, what we call it as a plastic state, gives you many important applications, which we generally referred as the thermoplastic materials. So today we shall discuss in a very generalized way about these thermoplastics, the pollutions these thermoplastics are creating, and also I would answer very frequently asked questions about these plastic pollutions related to the environment, and also the recycling technique in reference to the circular economy. Next slide, please. Yeah, let us start with this technology development through ages. Now, since your 10,000 BC to say almost your 1800, we had the age of a material sourced naturally, and they are being subsequently crafted. So what we call it as a age of natural resources and craftsmanship, where we have used natural ceramics, natural metals, means the metals and the metallurgical operations being done. And then came the renaissance of that your chemical age, what we call it as a industrial revolution and all. Since 18th century, we have that chemical age, 19th century, 20th century, 21st century, and we are still in that age, but the nature of the chemicals that we are handling, that has changed. So we begin with the small molecules, then we move to the large molecules, and we got an industrial revolution for that, where the polymeric materials took over, and then we move to the nanomaterials, and now to the biological age. We are dealing with so many materials having biological applications. So this age, what we call it as a synthesis, engineering, combinatorial, simulation, and strategies. Next slide, please. So if you look at the history of polymer science, polymers were the product of post-war renaissance in chemical industry, driven by the promise of inexpensive petroleum-derived feedstocks. So that was after during that Second World War, where we need this polymeric materials badly, and that actually acted as the driving force to develop so many polymers that we are seeing today. The 50s and 60s saw the introduction of many polymers that changed the face of human civilization, that we can realize that so many advantages we can have using these polymeric materials in almost all fields of applications. So that was what I would say the another driving force for developing many polymeric materials for uses. From early curiosities, polymers became an indispensable part of our daily living, and so omnipresent that we no longer realize how addicted nowadays we are to the polymeric materials. Really, we are now addicted with the polymeric materials. In all facets of life, you will see that we are using polymeric materials from our day-to-day to your more sophisticated applications. So that way we can say that we are now infested and addicted with the polymeric materials, with the use of the polymeric materials. Next slide, please. Now, if you see the development of these polymeric materials, the history says that it is a very old known material as long as 1500th century, where we had that your British explorers, they discovered the ancient Mayan civilization, where the children in Mayan civilization, they used to play with the natural rubber balls, right? Now, after that, in 1839, Charles Goodyear, he discovered that vulcanization process, by which he were being able to make that natural rubber more durable by reacting the natural rubber with sulfur in presence of fire. Now that vulcanization was named after that fire operation because Vulcan is the name of Roman god of fire. Since that rubber he made tough and durable and more elastic after putting it into fire after mixing with sulfur. So that with the process he named as the vulcanization, and till today we are using that name of vulcanization, that is a cross-linking reaction of rubber with sulfur. Then in the year 1907, another landmark year, the oldest recorded synthetic plastic was fabricated by Leo Baekeland, and that was bakelite. And we all know that the bakelite, which is actually a phenol formaldehyde resin compounded with carbon black. Uh, Till today, we see many uses of bakelite. One important use is that pressure cooker handles and all. So these are made from this bakelite. So it was discovered in 1907. Then in the year 1917, there was another landmark when X-ray crystallography was, that method was developed for analyzing the chemical structure, and that actually helped to unfold the your chemical structure of the polymers, particularly the natural polymers, and with the help of that, in the year 1920, Schrodinger, he were able to analyze the structures of polymers, and that really what we can say that the onset of the scientific journey of the polymers began almost 102 years back. Hermann Schrodinger, through his revolutionary publication Uber polymerization, he explained that how the polymer structure can be studied or can be known. Then after that, in the year 1927, vinyl chloride was produced on large scale, will actually help to synthesize many addition polymers, including PVC. Next slide, please. So thereafter, 1930, another landmark year when polystyrene was made industrially, followed by 1938 when Wallace Carothers made nylon. Now you see that within a gap of say 10 years, two different grades of polymers were produced, one of addition mode, another one with the condensation mode. So two different categories were being made in a gap of 10 years. Then in the year 1941, important year, polyethylene was developed. Uh, how much we use polyethylene nowadays. The most important commodity polymer is polyethylene. Then in the year 1970, that high temperature moldable polyester ethanol was developed. So that was again landmark year, considering the processing of the polymer at high temperature, product making at high temperature. So that technology was, established in the year 1970. Then 1971, important polymer Kevlar was developed. You know that Kevlar is a very strong fiber used particularly in defense application in huge volume, in armors and all. So that was developed in 1971, an important discovery that year. 1977, 76 rather, the plastics industry outstripped the steel industry as the nation's most widely used material per unit volume. So, in true sense, 1976, you can say that we entered into that polymer age, and which is still continuing. Next slide, please. Yeah. Uh, this is the present scenario of the uses of polymer in different facets of material technology. You see polymers we can have in the your polymers as a electronic material, polymer as a ceramic material in the form of composites. Then polymer as a composite material we can also use with you're both with organic and inorganic fibers, and also natural fibers. Then we have polymers being used for energy storage material. Then as a soft material, what we call it as a soft, intelligent material, smart materials particularly, and your biomaterials, right? So in all facets, you will see the presence of polymers nowadays. Next slide, please. Now, without going into much detail, I can give you a very simple classification of polymers. Now, based on the molecular engineering and eventually from the application perspective, we can have three different states of polymer possible. I just mentioned in the beginning that plastic is a state, so it is not a new polymer or a different polymer. What I would say, it's a state, it's a particular state of polymer that in that way we can have rubber as another state, similarly fiber as another state. So in the rubbery state, we can characterize the polymer by its long range elasticity, which is recoverable deformation and long range elasticity. On considering the mechanical strength, in the rubbery form, the polymers are rather weak. They are dimensionally unstable. You need to stabilize it through vulcanization, and can undergo high elongations even on application of low stresses. Now, the from the molecular engineering part, if you can develop a high segmental mobility within the polymeric chains, if you can develop the amorphous character, and if you can, develop the very weak interactions, so that can give you this particular property which characterizes the rubbery state of a polymer. Now, in case of plastics, in the plastic state, we have more strong interactions as compared to rubber. Some of the plastics, polymers in the plastic form or plastic state, they are hard, they are rigid, stiff, and dimensionally more stable, while you can have some plastics which are soft and flexible. And in the fiber form, mostly the polymers are in the crystalline form, and they offers high segmental interaction, low deformation characteristics, high rigidity, high stiffness, high strength. In fact, highest strength, and this in the fiber form, the polymer offers higher amount of reinforcement. So next slide, please. Next slide, please. Now, as I mentioned that we will be confined our discussion in the plastics. So these are the major uses of the plastics. You can see that most of the plastics are being used in the packaging film, about 35%, then about 25% in the building and construction, and then about 8% in electrical and electronics areas. Then furniture, housewares about 8%. In transport industry, particularly automobile, different automobile body parts and all about 8%. Now, in automobiles, nowadays, the amount of plastics being used is more than this figure actually, because of the objective to attain the fuel economy. Because if you reduce the weight of the vehicle, so that will apply less pressure on the tires, and ultimately the rolling resistance and all those properties will decrease, and that would give you more fuel economy. So nowadays about 40% of the vehicle weight is composed by plastics and polymers, particularly in the form of composites. Then in agriculture, about 7%. Uh, it is again increasing in these days because of a lot of uses of plastics, particularly in the areas of low rainfall. So in order to preserve the moisture in the soil, and also in the water storage bodies. So a lot of plastic films are being used. Then we have the mechanical engineering, that is the use of your engineering polymers and all, about 2%, toys and sports about 3%, medical about 2%. This figure is also increasing these days. Lot of medical applications from polymers and plastics. And then miscellaneous and others applications about 3%, footwear about 1%. So next slide, please. Now, advantages, why these plastics, particularly these polymeric plastics, these are being used in these applications. First of all, these are cheap. Then these materials are easy to clean, that is much lower energy surfaces they have. Durability, most important point, durability. Then therefore non-corrosive nature. Translucency, that is optical property. Translucency, there are many plastics which are transparent, so that optical property can be tailor-made. Then you have these insulation characteristics, both thermal and electrical insulation characteristics. Although you can have polymers which can be semiconductors, or which are called as a conducting polymers. So it is again it depends on the applications. If you need some conductivity, you can make the polymer extrinsically conductive or intrinsically conductive, as you wish. So that flexibility is there. Then lightweight, of course, these materials is much lighter in weight, and easily moldable or shapeable. Means you have to use a lesser amount of energy to get the product. Means the processing energy requirement is much lower as compared to conventional materials. Next slide, please. Further extension of the advantages into its benefits, this polymeric plastics, these has extreme versatility. Means as I mentioned, that the properties can be tailor made, and it has the ability to be tailored to meet very specific needs. Very specific needs can be met with these polymeric plastics. Lighter weights materials with the competing materials. Reduced fuel consumption during transportation. Extreme durability. These plastics materials, they are extremely durable, and they have a very good resistance to chemicals, water, and impact. They have good safety and hygiene properties for food packaging. We have several food grade plastics being available, used for this particular applications, hygienic applications. Then excellent thermal and electrical insulation properties, and again, if required, you can make them conductive. And relatively low cost that is involved both in terms of material and energy during the manufacturing of the products. Next slide, please. Now, very simple way to classify the plastics based on the thermal response. When you treat the plastics, it can give you two kinds of behavior. One is the thermoplastic behavior, means you can sequentially melt it. Then once you cool it, then it will solidify. Again, you can remelt it, and again you can solidify it. So that way it can be recycled. So when it has that property, we call it as a thermoplastic character. Then we have another specialized character, what we call it as a thermosetting character. That is, when you heat it, some chemical reactions will take place, and the polymer will become gel, and the shape will be set, what we call it as a thermosetting polymer. So you cannot recycle it in the conventional way that you do in case of thermoplastic, but it can be recycled using different technology. So one is thermosetting plastics, that is where the chemical reaction will take place when you heat it at a high temperature under pressure, and another case it will melt when you heat it, that is the thermoplastic plastics. So it will give you a plastic flow under heated condition. Then application wise, it could be commodity plastics, that is daily use plastics, low cost cheap plastics, and engineering plastics for engineering applications. Then based on the environmental degradability, it could be biodegradable or degradable in the environment. with microbes and non-biodegradable, which cannot be degraded in the environment. Next slide, please. Now, common examples of plastics and their key features. High density polyethylene, HDP, that's the way we abbreviate. They have high strength toughness. LDP, low density polyethylene, it is relatively low strength. Then polypropylene, it has high strength. Polystyrene PS, it is transparent, brittle. Polyvinyl chloride PVC, it is versatile but unstable, releases hydrogen chloride. So for that reason, you have to add lot of basic fillers in it. Then polyurethane PU, it is also a versatile polymer, means you can develop so many grades of polymers from polyurethane. Phenol formaldehyde resin, this is a thermosetting resin. It is brittle. Then you have urea formaldehyde resin, UF resin. It is scratch resistant. This is again a thermosetting resin. Then melamine formaldehyde resin, or MF. This is also scratch resistant thermosetting resin. Epoxy resin, lot of uses of epoxy resin. We do have thermosetting resin. It is tough. Then polycarbonate. This is an engineering polymer. It is transparent. Polysulfone engineering polymer. It is having much higher strength. Polyethylene terephthalate PET. It is also has a very high strength. It is a fiber forming polymer. It is also an engineering polymer as well. Acrylonitrile butadiene styrene, or ABS. This is also an engineering polymer. It also has a very high strength and toughness. Next slide, please. So let us see the uses of different polymers in different applications. These plastics. Your packaging, in the field of packaging, you can have flexible packaging, rigid packaging, bottles, jars, food containers, bags, and film packagings. And you see LDP is used mostly in packaging, almost 45%, then followed by HDP about 25.4%. Then we have polystyrene, PET, and others about 9.6%. PET, it's amorphous and crystalline in both form. PETs are being used in packaging. So next slide. Yeah, building and construction industry in the form of pipe, conduit, and fittings, insulation, floorings, etc. PVC is used in huge amount in this industry. PVC, particularly your doors, windows, pipes, and nowadays you can see your tiles made of PVC, PVC floorings, PVC mats, and all. So a lot of uses of PVC in the building construction industry. Then you have the phenolic resins, the laminates and all made from these phenolic resins. Then you have HDP, urea formaldehyde resin, polystyrene, unsaturated polyesters, particularly these unsaturated polyesters used in paints. So these are the polymers which are mostly used in this building and construction industry. Next slide, please. In consumer and institutional products, you have disposable food serviceware, healthcare, and medical products, toys, and sporting goods. And you see polystyrene being used in maximum amount in this sector. Then you have polypropylene, high density polyethylene, low density polyethylene. So these are the mostly used polymers in this field, followed by some PVC and PET as well. Next slide, please. Now let us come to those allegations that we frequently make on plastics. It produces endless garbage. Plastics, polymers, they produce poisonous smoke, marine debris, sewerage problem, particularly in every monsoon, problems in agriculture, and problems with the animals taking these polymeric plastics as food, and subsequently they are dying because of that. Next slide. So proofs of these allegations, you see the garbage. How often do we see this sort of garbage being stacked in the roadsides, in your grounds and all? So this is the picture of that. Next slide. Yeah, plastics being incinerated in uncontrolled fashions. It is claimed that it produces so many toxic fumes like carbon monoxide, hydrogen chloride, ammonia, hydrogen cyanide, phosgene, benzene, phenol, acrylonitrile, aldehydes, isocyanates, methyl methacrylates from different kinds of plastics which are being incinerated uh, in uncontrolled fashions, and they are creating environmental hazards. So next slide. Yeah, the picture of marine debris. These are being collected from undersea, and you see these plastic bottles and films, plastic films, packaging films, and all. These are being recovered from the marine water and your from this marine water. These are being recovered and stored in the seashore. So I mean, a huge part of this marine debris, this is composed of this polymeric plastic. This is a picture from Hawaiian island where these are the things being recovered from seawater. Next slide, please. Sewerage problem. This is the local in your locality. Every monsoon you will see this picture. Everywhere these plastic carry bags, these are being floating. Uh, these chokes the drain and the sewerage lines, and it creates this waterlogging problem. So next slide. So because of this dumping of these waste plastics, it is often said that the fertility of the soil is gone because of the leachates that are mixing with the soil, and also the breathability of the soil is gone because of this plastic being stored. But the point is, these are not being stored in the agricultural area, but still it is claimed that the soil loses its breathability and all, and I mean your fertility of the soil is destroyed because of the dumping of these waste plastics. Next slide, please. Yeah, this is what we are mentioning, that the animals, they are taking these plastics as a food, particularly these stray animals, this cow. How often this cow, I mean, we see that cows, they are chewing the plastic carry bags, and also because of the these plastics present in the seawater, the turtles and all, which loves to feed on these your jellyfish and these plastic films, these transparent plastic films. They look alike jellyfish, and these sea turtles, they used to consume that, and afterwards these chokes their stomach, this chokes their your breathing pipe, and I mean that actually causes their death. Next slide. Yeah, this is for the sea turtles. Next slide. Now, after looking at all this, what are the frequently asked questions on these plastics and the environment? So I would state all those questions, and I will answer those questions. Now, the first question is, you please click on the questions would come. Yeah. So after all this, can we say that are these plastics eco-friendly at all? Now, what do we mean by the eco-friendliness? Now, anything or any process, any material, if it does not put any load on the environment, then only we can say that the material or the process is eco-friendly. But do we have any process that does not put any load on the environment? I think the answer is no. So that way, eco-friendliness, this is not actually a technically correct term, I would say. Eco-friendliness means you cannot have any material technology, any process technology that will not offer any load on the environment. You cannot have that. So eco-friendliness, you need to judge that which process, which material technology is offering less load on the environment. So from that perspective, you can say that this process is eco-friendly, this material is eco-friendly, or this material I mean, synthesis technology is eco-friendly. So that is the way we should consider. So sustainable development that we talk about with this nowadays, that we need a sustainable materials and all. So that really banks on this particular point, that which material takes or consumes less amount of energy to be produced, and while we make any product from any material, how much energy we are offering it for its production. So considering all those points, we have to conclude that whether a material is eco-friendly or not. So in that way, even when you are making a paper, it's not at all eco-friendly. Rather, I would show you it is much less eco-friendly than plastics. Now, so from that point of view, you cannot only blame plastics that it is not eco-friendly. So almost all your materials that you are having today for use or for any applications, none of these materials are eco-friendly, right? So you need to compare only that which is more, I mean, eco-friendly and which is less eco-friendly. So you cannot just say that this is eco-friendly, right? So it is not I mean, a straight cut, I would say, judgment about the eco-friendliness. So next slide. Are plastics responsible for utilizing a major share of the world's oil or hydrocarbon resources? So many of us think that, and because of the so much of voluminous productions of plastics nowadays worldwide, so is it consuming more of the petroleum oil resources, or because of these huge production of plastics, the oil resources are depleting very fast? But the answer is that only 4 to 5% of these crude oil resources are being used for the production of the plastics. That is the monomers that we synthesize through distillation and cracking. So it is not that by producing so much of plastics globally, we are consuming or this crude oil faster or helping it to deplete faster. So that is a wrong idea we are having. Uh, next slide. Next question. Yeah. Do plastics make up a large part of the municipal solid waste, particularly after seeing those heaps of waste plastics being, I mean, stacked? So one may think, or it is our natural thinking, that most of the municipal solid waste is nowadays is composed of the plastics. Now I can give you one data, though it is little bit old, but that it would clear your idea, that a study conducted by the National Environment of Engineering Research Institute, Nagpur, for the Brihan Mumbai Municipal Corporation, or BMC, puts this figure to about 0.75% only. Even in Europe and USA, where you have the per capita consumption of these plastics to about 110 kgs or 65 kgs, in that number, so there also you'd see the plastic waste makes up of only 8% of the total municipal solid waste. The rest is made up of organic materials of about 33%, paper and boards about 30%, glass and metals of about 16%, and others about 13%. Next slide, please. Yeah, are plastics hazardous when buried in landfills? Now, plastic waste does not generate toxic leachates which contaminate the soil or groundwater resources. On the contrary, those products which do biodegrade with byproducts may result in contaminating the groundwater resources. Now, mostly these carry bags, these are made up of LDP, and you know that while processing LDP into these carry bags, we hardly require any plasticizers or any other materials, right? So that way, when these carry bags, mostly these carry bags compose the, waste, solid waste in the municipal, waste. So when these carry bags are being dumped, very little chance that anything comes out of that material and contaminates with the soil. Now, only small molecular weight liquids can leach out with time and contaminate. Since these carry bags, they does not contain any plasticizers and all, so there is almost no chance that anything is coming out, leaching out of this material, plastics material, and contaminating the soil. Whereas those organic materials which biodegrades rather, so they create a lot of byproducts during the biodegradation, and while those byproducts they are mixed in the soil, they can create a lot of pollution problem, but we do not consider that because we consider them as a biodegradable and so-called eco-friendly materials. Next. Is plastic at all recyclable? Of course, it is recyclable. Thermoplastics, they can be recycled much easily rather. Whereas thermosetting plastics, although the shape is set because of the chemical reaction, but still it can be recycled, and I will show you what are the techniques being adopted for recycling of the thermosetting plastics. So in totality, you can say that all sorts of plastics, both thermosets and thermoplastics, can be recycled. Next. Do plastic bags contain plasticizers? No, of course. These are mostly made from polyolefins, which does not require plasticizers for their processing. So that way, that leaching problem, contamination with the soil, these problems are not actually possible with these plastic bags. So your next slide. Does the burning of plastic generate toxic fumes? Now, polyethylene, which is a hydrocarbon, when you burn it, it will produce carbon dioxide and water. When you burn PVC, it will produce hydrogen chloride, but that hydrogen chloride actually, your hydrogen chloride which is produced, that actually retards the burning of the rest of the PVC. Right, so that is the advantage of getting the hydrogen chloride being released at the initial stage of the burning of the PVC. Now, since most types of combustion produce dioxin, it is inaccurate to blame any specific material for dioxin production. Now, it is often blamed that PVC and many other your oxygenated polymeric plastics, they produce dioxin when they are being burned. But let me tell you that many organic materials, when they are being burned, they can also produce dioxin. So it is not, a question of blaming only plastics for producing dioxin and also producing carbon monoxide. Any organic material, if these are burned in insufficient oxygen, they will produce carbon monoxide. So it's not that only plastics that they would produce carbon monoxide, but again, if even these hydrocarbons, if they are being burnt with full oxygen, they will eventually produce carbon dioxide and no carbon monoxide. Now, regarding production of this dioxin, we have a figure to state that after a fire in a PVC a recycling warehouse in Germany, dioxin levels in fire gases were measured to be only 1.5 nanogram per meter cube. So this is a fact, this is a figure which says that amount of dioxin which is being produced after burning PVC, which stands to this figure. These we have not finished the last slide, please. Yeah, these amount of dioxin you can found in the unrestricted agricultural soil, means where you have some unrestricted agriculture practice. So even there you can have the presence of this amount of dioxin. So why to blame plastics for this? All dioxin created in the process is destroyed before the process of burning is finished, and it is not, but emitted in the environment. So this is the this actually what happens with this dioxin, fate of the dioxin. So let us first learn about it and then start blaming. Next slide now. Do plastic bags contain titanium dioxide and lead-based components which are toxic, and dyes used in colored bags cause severe health hazards? Now, most of the opaque bags they contains titanium dioxide, and it is assumed that the lead-based components are also present. And when you have these colored bags which contains these dyes, will does this dye causes health issues? Now, the answers, that is the titanium dioxide, the use of this titanium dioxide is permitted by Bureau of Indian Standards in food contact applications. So nothing to worry about. The inorganic pigments that are being used, these are of inorganic origin, right? These pigments, they do not contain lead or cadmium, right? Nowadays, we are aware of it, the ill effects of this lead and cadmium. So the lead cadmium pigments, these are not recommended for use. Dyes, these are organic in nature, so they are more compatible with the organic polymer. So the chances of their leaching out from the polymer is very less. So next slide. Now, very important question. This is, what is the essence of the plastic bags being thick or thin? Very often we do hear this, point that you cannot use carry bags less than say 5 micron or 10 micron, 20 micron, something like this. So what is the essence of this? Basically, these does not have any technological background. Now, when you are making a thick carry bag, means you have to use more materials, and your processing condition is going to be a little bit more sophisticated. Now, when you will be producing a very thin carry bag, you can do it easily with lesser amount of polymer and materials. I mean, the process cost, right? So thin bags are cheaper and they can be produced very easily. And thicker bags, you need to require some more capital cost at the first instance for producing this. So what we say, that the thin bags, thin carry bags, these are being produced by the your small entrepreneurs, and big entrepreneurs, comparatively big entrepreneurs, they produces the thick bags. Now, if you cut down the use or supply of these thin bags in the market, then actually you are reducing the supply chain, or you're cutting the supply chain into the market, these carry bags. So that way you are trying to reduce the usage of carry bag. You are cutting down the supply, right? So it is just eliminating a fraction of the entrepreneurs from this supply market, and that way to control the use of carry bags and subsequently the pollution created by the carry bags, or the hazards created by the carry bags. So there is no technological background behind this, only to cut down the supply of a certain fraction of carry bags. So that was the policy, and it has almost no technical issues behind. Next slide. Now, very important questions nowadays being debated. Should we change from plastic to paper bags? So let us see how eco-friendly, how much eco-friendly rather, paper is. It is the fifth largest consumer of energy, about 10% of all industry energy consumed. So impact on environment, you can just judge from this point. Plastic grocery bags consume about 40% less energy than paper. 1.34 million versus only 0.58 million megajoule for 1 million bags production. Plastics generate about 80% less solid waste, produces 70% fewer atmospheric emissions, release up to 94% fewer waterborne wastes. 1 metric ton of paper requires felling of about 10 to 17 trees. Paper cannot be recycled indefinitely. It can be recycled to a maximum of 4 times, whereas plastics at least 5 times you can recycle. Paper is the third largest industrial polluter to air, water, and land in Canada and in the United States. So you can see that how much eco-friendly the paper is going to be if you replace plastics with paper, polymeric plastics with paper. Next. Now, plastic bags choke stray cattle that unwittingly chew them. How can this be justified? Do we at all require to justify this? Because the plastic bags, these stray animals, they are chewing, is being littered by us only. So if we were careful in dealing with those carry bags, instead of throwing them, in the roads and outside our house, then how come these animals would chew them? Right? So it is not, blaming the material. It's not the question to blame the material. Rather, the blame should be on us, that the littering we have done it, right? So it is not a question to justify that the material is bad, the material is not useful, the material is creating problem. Rather, it is our poor understanding about the material that is creating the problem. Next point. Next slide, please. Yeah, do plastics meet the criteria of resource conservation? That is, do we get more for less while using plastics in packaging? So you see plastics, polymeric plastics, mostly it is used in packaging, almost your 40 to 45%. So what is the justification? Why it is so much, used in the packaging areas? So do we really get, more for less? That is, by using lesser amount of plastics, do we are able to get more material being packed? So let us see. Next slide. Yeah. So you see first the weight of packaging material in the left. So say 20% packaging material, paper and board 43%, then glass 19%, metals 14%. So when you have these percentage of materials being used in packaging, right, or when they are being used in packaging, then how much material they will be able to pack? So you see, just compare that with 20% plastics, you are able to pack 53% material, while with say 43% paper or board, you can only pack 25% of the material. And so for the glass, about 19% of glass can give you 10% of the packing of the material. So you can see that how much you can get, almost more than double, right? More than double of its weight of material can be packed using the plastic. So that is the reason why we are using so much of plastics, polymeric plastics in packaging, in different types of packaging. Next. Yeah, more statistics. 500 grams of coffee powder. If you want to pack, then you require 500 grams of glass jar or tin plate container of 130 grams, or plastic laminated pouch of only 12 grams. So you can see a 12 grams plastic pouch can pack 500 grams coffee. Similarly, 1 kg of salt you can pack just by using a plastic pouch of 5 grams. So with this, you can achieve almost 200:1 with the materials being packed with the unit of material or plastic, polymeric plastics being used as packaging. So in true sense, you are getting more for less only from this polymeric plastics as compared to other conventional packing materials. Next. Well, Now, after finishing this question answer part, let us move to this degradability characteristics. We know that based on the degradability, we can have biodegradable plastics which decomposes in sunlight into small molecules, and later on the
Sir, your voice is not coming, sir.
can you hear me now?
Yes, sir.
Okay. Next slide, please. Yeah. So biodegradability, which is a property of the polymer. Uh, so we have your four kinds of these biodegradable polymers that is based on their source. One is from the biomass products, which are called the agropolymers like polysaccharides, some proteins also. Then we can have polymer source from microorganisms. These are also biodegradable. Polyhydroxyalkanoates, the family of polymers. Then from biotechnology, by using biotechnology, we can synthesize polymers, biodegradable polymers like polylactides, and also from purely synthetic roots, that is from the crude oil sourced monomers, say for polycaprolactone, polyester amides, polybutylene adipate, co-terephthalate PBAT. So these are the polymers which have this biodegradability. Next slide. Now these are the uses, both as a packaging material and as a molded goods. These biodegradable plastics can be used. Next slide. Now their advantage, mostly they are synthesized from biological sources. They are 100% biodegradable in the environment. They also have the processability like commodity plastics, but still this is not a viable solution to replace the purely synthetic non-biodegradable plastics with these biodegradable plastics because of the cost factor, particularly in a developing country like India, that if you find the product cost has suddenly increased because of the use of biodegradable plastics, then you will not buy that product. So the company will make a loss and they will be reluctant to replace the material technology. So in the first world country, this is a welcome step, but not in a developing country like India. Not every product, particularly the consumer products, the daily use products, you cannot replace with this biodegradable polymers. Next. Yeah. So next slide. Well, what we have discussed so far, this material technology on these polymeric plastics, their uses, the disposal problems and all. So these polymeric plastics and almost all other materials technology nowadays that drives our economy basically follows a linear economic model. And this linear economic model is that you take, you make, and then you dispose, right? So this is the open-ended economic model that we are following, and that actually does not speak about the sustainability that we are debating nowadays, right? So, and as long as we are following this linear economic model, we will never be able to achieve the sustainability, because at the end you are actually disposing the material in the environment, right? So that creating the load on the environment. So as long as you are following this open-ended model, you will not be able to achieve the sustainable technology. No technology is going to be sustainable in this model. Then what is going to be the most feasible model? Then we talked about the circular economy, which is a closed loop model. And in this model, next slide, please. Yeah, in this model, we have a system-based approach to economic development and a paradigm shift from the traditional concept of linear economic model of extract, produce, consume, dispose, and deplete to an elevated echelon of achieving zero waste by resource conservation through changed concept of design of production, processes, and material selection for higher life cycle conservation of all kinds of resources, right? So in this model, the concept has changed. That is, you have to get back something from the material, right? So that is the, in a very simple way, we can interpret this model that either in the form of energy or in the form of material, you have to use the end life material as a feed to the other process. So you cannot just throw it and break this cycle. You have to use it in somehow or other in other process in this economic model, and that way you will be able to achieve the sustainability. Next slide, please. So in this economic model, we have the four categories of waste. First is the wasted resources, use of materials and energy that cannot be effectively regenerated over time, such as fossil energy and non-recyclable materials. These are regarded as the wasted resources. So in terms of resource also in circular economy, we consider these as the wastage. Wasted capacity, products and assets that are not fully utilized throughout their useful life is also a wastage, and that is what we consider as a wasted capacity. Wasted life cycles, products reaching end of use prematurely due to poor design or lack of second use options is also considered as a waste. That is the wasted life cycles. And wasted embedded values, that is the components, material and energy not recovered from the waste streams. So that is also considered as a wasted embedded value in this circular economic model. Next slide, please. Yeah, so there are 5 ways to create the circular value. Circular inputs, the use of renewable energy, bio-based or potentially completely recyclable materials. So in your material processing technology, if you concentrate on use of these sort of materials, then what we consider is as a circular inputs, and that particularly creates a value chain in this circular economic model. Sharing platforms, increased usage rates through collaborative models for usage, access or ownership, that also creates the value chain in this model. Sharing the platforms. Product as a service, offer of product use with retention of the product at the producer to increase the resource productivity is considered as a considered to offer a value chain in circular economic model. Product use extension, prolongation of product use through repair, reprocessing, upgrading and reselling is also considered as offering a value chain in this model. And resource recovery, that is recovery of usable resources or energy from the waste or byproducts, also offers value to this model. Next. So here what we have seen out of these 5 points, that is circular inputs, product use extension and resource recovery. These models mostly focused on the production technique or technology, and the rest of the two, that is sharing platforms and product as a service, they target the consumption and the relationship between the product and the consumer. Essentially, the models cover the full value chain of circularity. Circular inputs focus on the ingredients that go into products at the design, sourcing, and manufacturing stages. These inputs, such as renewable resources, aim to eliminate wasted resources and are a stepping stone for all other models. In some of the more advanced examples, circular inputs can go beyond zero waste to be resource additive, that is, where waste streams are processed into material streams. Product use extension focuses on maximizing the use of a product. To do so, companies must start from the very beginning, especially product design and responsible sourcing, in order to avoid wasted life cycles and keep products in use for as long as possible. In addition, product use extension plays an important role in enabling the product as a service and sharing platforms models. Next slide. So how we deal these polymeric plastics in circular economy? Our relationship with polymeric plastic needs rethinking. Plastics are versatile materials, but the way we use them is incredibly wasteful. We take oil and gas from the earth to make plastic products. They are often designed to be used only once, and then we throw them away. This is true for the carry bags. Each and every day we used to go to market, we used to go to bazaar empty handed, and whatever we used to buy, we expect the seller will pack them in a carry bag, and we used to carry them. So each and every day we are, carrying a new carry bag to our house, dumping them, and after a few days we used to throw them out. So it becomes only a single use carry bag technology. So this is what we call a linear take make waste model. Year on year, millions of tons of plastic worth billions of dollars ends up in landfills, is burned, or leaked into the environment. A staggering 8 million tons leaks into the ocean every year, and that number is rising, and you can see it from the amount of marine debris that are being recovered every year. If we don't rethink its use, there will be more plastic in the ocean than fish by weight by 2050. So it is estimated. Next slide. So here is the present model you see, that is about 78 million tons of annual production of plastics. About 32% is leaked, 40% is landfill. Only 14%, 14% is collected for recycling. Same amount is incinerated. Now, out of that 14%, about 4% is a process wastage. 8% goes for the cascaded recycling, and only 2% is available for closed loop recycling. So you can say about 2% is in circular economic model and 98% is in linear economic model. This is the present day picture with the polymeric plastics. Next. Now, how to create circularity in plastics? First, from that raw material input point of view, is eliminate the plastics we don't need, right? Particularly say carry bags. These carry bags, do we require these carry bags? We can use the bags, the jute bags and other bags, which we can use it for everyday marketing, right? Everyday your while you go for this market, so you can carry these bags every day. So these, first of all, these carry bags we can eliminate from our daily use. Innovate to ensure that the plastics we do need are reusable, recyclable, or compostable. Circulate all the plastic items we use to keep them in the economy and out of the environment. Next slide. So what are the 6 visionary then for plastics, polymeric plastics in circular economic model? Elimination of problematic or unnecessary plastic packaging through redesign, innovation, and new delivery models should be the priority. Reuse models should be applied where relevant. That should reduce the need for single-use packaging materials particularly. All plastic packagings to be 100% reusable, recyclable, or compostable. All plastic packagings to be reused, recycled, or composted in practice. The use of polymeric plastic should be fully decoupled from the consumption of finite resources. That is, need to develop a technology from which we can develop plastics from natural resources, green resources. All plastics packaging should be free from hazardous chemicals, and the health, safety, and rights of all people involved in this material technology should be respected. So next slide. Regarding this reuse, there should be or could be 4 reuse models. One should be, say, refilling at home. That is, while you are refilling the packaging plastic or that packing jar or whatever made from polymeric plastics, you can refill it at home, or you can return it from a home for reusing, or you can refill on the go, or you can return these containers, packaging materials on the go. So there could be these 4 reuse models. Next. Now, why to promote this reuse? This reuse can cut costs. It can adapt to individual needs. It can optimize the operations. It can sometimes also build the brand loyalty, that if a particular brand packaging material, if you are using for long, reusing for long, so that might create the brand loyalty. It can improve the user experience, and also it may give I mean some input for gathering intelligence. Suppose the producer may create an app to monitor that how this packaging material is I mean reused after the content is finished, whether it is being thrown away or it is being being reused in the home. So that app might give some information, or some chips can be installed in it. So some sort of intelligence I mean technology, intelligent technology can also come up with these reuse models from the point of view of the producer. So next slide. Plastic waste, of course, is a global concern, although we are responsible for this, but it is a fact that it is a global concern. Now, the per capita consumption you see in US 109 kgs, Europe 65, China 38, Brazil 32, and in India it has increased now to 11 kgs. The global average is about 28 kgs nowadays. So once plastic is discarded after its utility is over, it is known as the plastic waste. It is a fact that plastic waste never degrades, particularly the plastics, the commodity plastics, and remain on landscape for several years. Mostly plastic waste is recyclable, but a few recycled plastics could be harmful to the environment as these contains additives and colors. So in this circular model, we need to eliminate those particular plastics or those ingredients which creates this sort of harmful effects in the post-use I mean duration. Next slide. So in order to alleviate your these I mean polymeric plastic harmful effects, we need for polymer recycling. It should be promoted because some of these effects, harmful effects that these are non-biodegradable in nature. Waste disposal mismanagement, uh, creating pollutions in oceans in the form of microplastics, because with time these disintegrates and and they spreads in the form of microns size plastics, that what we referred as the microplastics. So that is a big challenge nowadays in the ocean. Then food chain upset while the animals they consume it, so that creates a food chain upset. Then natural resource pollution, that is these microplastics, this could eventually pollute the groundwater, the air and water resources. Next. So you see the sources of polymeric waste. About 60% wastes are created from the packaging fields, the packaging plastics. So about say 40-45% consumption of plastics in packaging is creating about 60% of the waste, right? So it is huge that we are having. The other waste, that is the waste created from other fields, they are nominal. Building construction about 5%, automotive about 5%, electronic about 8%, non-packaging households items creating about 4% wastage, agriculture about 5%, and collectively the others about 14%. Next. Now, while you go for recycling of this plastics waste, the first and the foremost thing or the step that you need to adopt is the separation of different types of plastics, because in the waste you will find it's a mixture of different natured plastics, different polymeric plastics, they are being mixed together. So first important step is the separation or segregation of these plastics, because not all plastics are being processed at the same temperature range. Since the plastics which are being produced to different packaging items or for different products, they are being processed at different temperatures. So while you will be reprocessing them, you again need to follow that protocol. So the first important step is the separation of these plastics, different polymeric plastics from the waste. Now, thing is that since these for the recycling industry, these your raw material or the input material is the plastic waste, which is to be collected, in a very bad condition, from a very dirty conditions. So you won't find any learned technologists who will be working for you to do these separation operations, right? So it has to be done by the layman's, and you need to design such simple separation technologies so that even without having any knowledge, technical knowledge about different plastics, the layman can do this separation job. So that is again a very big challenge for the recycling industry. That is the collection of this input these input raw materials, that is the waste, and its separation. Now, the first technique that can be applied is the gravity separation. That is by using these air classifier or ballistic separator. That is the dry techniques. Using this, it can segregate between the lightweight plastics and the heavyweight plastics. And wet techniques can also be used. Simple technology, just sink float technology, that is in water. You separate it, and whatever is sinking, you separate that. So these are the simple techniques that are being used for separation. Second, next slide. Yeah, electrostatic separation, sometimes based on the rubbing, is rubbing together these plastics waste particles of different characteristics. They result into the transfer of electric charge and surfaces are thus affected by different electrical charges which allowed to perform separation inside the electric field. So this electrostatic separation sometimes becomes very useful. Then magnetic density separations based on the presence of the magnetic quality of the, particularly the ingredients present in the plastics. This sort of magnetic density separations can be done. Next slide. Sensor based separation. Uh, Sometimes these sort of high profile sensor based separations can be done for the complicated plastic items which contains multiple plastics which cannot be easily separated using those earlier techniques being mentioned. Next. Now these are the different phases of recycling. First of all, of course, is the collection, followed by sorting, then washing, then shredding, then processing or manufacture, and finally to get the recycled pellets for further production. So 6 total steps to be followed in recycling of thermoplastics particularly. Next. Now this recycling, there could be primary recycling, then you can have mechanical or secondary recycling, chemical or tertiary recycling, and quaternary recycling. So 4 ways to recycle both thermoplastics and thermoset, and it depends on the material that you're handling for recycling. It's not that all polymeric plastics can be recycled in all 4 modes. It depends on the individual polymers, which techniques to be adopted for its recycling. Next. So in primary recycling, the primary recycling consists in processing of a known and uncontaminated material, usually a scrap from the industrial processes. This recycling process leads to a product very similar to the virgin one when the performance is required. In secondary recycling or mechanical recycling, it is a similar processing of the materials, that is separation and washing. Since the material is a post-consumer waste and it is contaminated with many kinds of residues such as organic compounds and other polymeric materials. As a consequence of the secondary treatment, the material properties decay in a cascading effect, what means that are depreciated every time the material is reprocessed. Just you can consider the mild reprocessing of these your carry bags. So every time you remelt it, reprocess it, some sort of molecular weight breakdown takes place and the property deterioration occurs. So finally, after 4 to 5 times recycling, the carry bags are being made black in color by adding carbon black to hide out the surface, your yellowing and these molecular weight breakdown effects. So these black carry bags, they are at least 5 times recycled thermoplastics. So tertiary or chemical recycling, it corresponds to the depolymerization of the polymer chains and thus the recovery of the original monomers and oligomers of various molar masses. Nowadays, this technology is being tried for many polymers, and at this moment I can say that SABIC has commercialized this technology and they are recovering the monomers from the already used products, and these monomers they are utilizing for remaking of the polymers. So this comes under this tertiary or chemical recycling process, and quaternary recycling is the recycling where the energy recovery is being done, because in this technology, if you find means when you see that your polymeric plastics is not capable or suitable for recycling in first 3 modes, then at least you need to recover the embedded energy from it, which comes under this quaternary recycling or energy recovery. Next slide. So some specific ways to recycle the thermoplastics. Let's see. Next. So before going into this recycling, let us first see the your recycling codes. I think all of you have noticed these numbers in the various plastic products. So when number 1 is written, first of all, these arrows, they indicates the recycling, and these numbers, they indicate the specific polymers that are being used. So number 1 means the product is made from PET. I mean, PET in the virgin form is good. For long use, it may start to deteriorate. PET. Number 2 stands for HDP, high density polyethylene. Recycled product is equally good to that of the virgin HDP. PVC, number 3 stands for PVC. PVC, recycled PVC is not so good. LDP, number 4 stands for LDP, low density polyethylene. The recycled LDP is also equally good as that of virgin. Number 5 is PP, polypropylene. Recycled polypropylene is good. Just as your virgin PP. Polystyrene, also recycled polystyrene is safe to use. Number 6 stands for that. And number 7 stands for other miscellaneous polymers. Next slide, please. Now, regarding recycling of PET, PET is generally recycled through a chemical recycling route. These are the reactions that are being conducted for recycling the PET, that is to get down the molecular weight, alcoholysis, aminolysis. This lysis term stands for downgrading the molecular weight, that is breaking the long chain. So aminolysis, ammonolysis with the help of ammonia, then hydrolysis of PET, that also reduces the molecular weight, and glycolysis. Next slide, please. Yeah, glycolysis. So these are the 5 chemical routes by which the PET can be recycled. And this table tells you that what techniques are mostly being industrialized and what are not, still in the laboratory scale. Next slide. Recycling of LDP and HDP. Advanced processes of chemical recycling of polyethylenes are now being practiced. For example, pyrolysis, gasification, liquid gas, hydrogenation, etc. In catalytic pyrolysis, there could be 2 processes. One is the CAT-POM technique, which implicates the use of cetyl trimethyl ammonium polyoxomethylate catalyst used for this catalytic pyrolysis, where the polymer is degraded at a temperature of say 220 to 240 degrees Celsius within 1.5 hours. And the second technique is ZSM5 technique, that what we call it as the aluminosilicate zeolite technique, where the polymer is degraded at a slightly higher temperature of 260 to 280 degrees Celsius. Now, upon degradation, a liquid fraction of polyethylene is obtained, and it gives about 73% yield, which is quite good, using the CTA-POM technique, whereas the second grade of catalyst gives only 44% yield. This liquid fraction contains about 87% petrol-like hydrocarbons, that is C7 to C16 fraction, C8 to C13 fractions, and C16 to C18 fractions in case of LDP, while in case of HDP, it contains about C8 to C12 fractions and C2 to C4 stocks, which includes alkanes and alkenes. Next. For polystyrene, we have dissolution technology for reusing, recovering the polymer. Limonene, which occurs in citrus fruits. This limonene has been found to dissolve polystyrene. So for the polystyrene products, they can be dissolved in limonene. Then the polystyrene can be recovered by using a non-solvent. Also, some catalytic degradation of polystyrene is useful. It gives about 65 to 70% yield of the monomer by using certain catalyst, and also controlled pyrolysis of polystyrene, giving the depolymerization of polystyrene, leading to the formation of the monomers for repolymerization. So these are the practices of recycling of polystyrene. Next slide. Recycling of PVC. PVC mostly incineration is being done, which produces hydrogen chloride, and that technology is not very much, recommended. Now a new technology has come up, what we call it as a NTK Vortex pyrolysis process, which produces various products from PVC. Next slide. So here you can see that you can get calcium chloride containing products, because in this technology calcium chloride is used to suppress the elimination of hydrogen chloride from PVC. And apart from that, coke and the metal compounds which are used as a stabilizer for PVC. So all these can be recovered using this updated technology on PVC recycling. Next. Yeah, recycling of multi-layer plastic packaging films. So this has been a big concern, how to recover this multi-layer polymeric packaging films, because in this multi-layer films it has presence of different polymers. So here the stage-wise dissolution technique is being used, whereby selective solvents are being used stage-wise to recover polymers present in different layers. So first, the stage-wise solvent dissolution technique is applied, whereby different polymers are being dissolved in different solvents. Then the specific non-solvents are being used in respective polymer solution to recover the respective polymers. So this is the technology which is being used for recovering different polymers in a multi-layer plastic packaging films. Next. Recycling of thermosets. I mentioned that we have to adopt a different technology for thermosets. We need to go for mechanical recycling, which is mostly the pulverization. Then thermal recycling, combustion, fluidized bed technique and pyrolysis, and chemical recycling, that is chemical decomposition and these chemical decomposition using supercritical fluids like supercritical carbon dioxide. Next slide. So in mechanical technique, pulverization is used, whereby these thermosetting products, they are being pulverized into very small particles, and they are being used as a reinforcing material for other thermoplastic composites or any other composite making process. Controlled combustion, recovering the lot of energy, because it is estimated that about 30,000 kilojoule per kg of energy can be recovered from the thermosetting plastics. So by a controlled combustion technique, this energy recovery is being done. In fluidized bed technique, it is an interesting deployment oriented for thermosetting composite materials recycling, that combines the advantages of recovering the calorific value of the resin while recovering the fibrous fraction of the material. So this is what we can say a more technologically upgraded combustion technique, whereby the residual fiber kind of material is recovered, which is mostly the carbon fiber recovered from the thermoset. Along with it, the embedded energy is also recovered. Now pyrolysis is a thermal decomposition, whereby the thermoset material is pyrolyzed or is being heated in an inert atmosphere by rupture of the chemical bonds. and to recover the useful material from it, mostly the carbon fiber material through the pyrolysis technique. Next slide. Now this is the chemical decomposition of the thermoset, whereby the chemicals are being used, specific chemicals are being used for the breakage of these chemical linkages in a thermoset, so that the material can be it get transformed into oligomers, monomers, and sometimes some useful materials for its reuse. So next. So this chemical decomposition, this technique can further be carried out using supercritical mediums, a supercritical carbon dioxide, which actually gives the technological upgradation of this process. That is, the process becomes more efficient once this reaction is carried out under supercritical condition. So here we have come to the end of this presentation, and I would like to conclude that this plastics, it's a very useful material, particularly this polymeric plastics, various applications, widespread applications, tailor-made materials, so useful. So only thing, we need to learn how to use it. The plastics education, plastic management is important for common people. So as a technologist, it's our job to educate the mass by I mean, how to offer them, or to conduct the your workshop, training, and whatever, make them aware that how to use these plastics, because this is a precious material. And because of our these actions, litterings, what kind of problems we are creating for us. So this sort of plastics education is very, very is a necessity of the hour. And from the government, we need more promotion of this recycling industry. This recycling industry at this moment in India, only say 10 to 15% of the waste plastics is being recycled. So we have to take it up by the help of the government support. So we need to frame a particular policy for upholding this recycling technology, so that it fits into this circular economic model, and this technology becomes more sustainable for the future applications and future use. So thank you very much to all of you for your patience hearing. Now, if you have any queries, questions, I would be happy to answer.
Thank you very much, sir. The session is now open for interaction. If any participant has any question or anything to know from sir, they can raise their hands. And offline participants also, if you have anything to interact with sir, the session is open. So if anyone has anything to interact with sir, the session is open. So there is a remark that the session is very informative. If there is no questions or nothing to interact with sir, then I would like to thank sir for spending his valuable time for discussing and sharing with us such an informative session related to the consumer and institutional products, then how the marine debris on the beach and sewage problems, then problem in agriculture, then there are many frequently asked questions related to plastics and the environment had been discussed, just like essence of plastic bags, transition from plastic to paper, eco-friendly needs, then plastic packaging, biodegradable polymers, linear economy, circular economy, techniques of separation of plastic waste, need of reuse, plastic waste and global concern, need for polymer recycling, and we have got many new information from this session, and I hope all the participants has got many new information related to the plastic reuse, recycling, and how the eco-friendliness can be enhanced. Thank you very much, sir. Thank you very much
Thank
for
you.
your
Thank
valuable.
you. It's my pleasure to be here. So thank you, all of you.
Thank you, sir. So it's now 1:32 p.m. So lunch break is there. So at 2:30 we will meet again. The talk will be by K.A. Rajesh, Joint Director of CIPET IPT Kochi. So for the online participants, the link will be same. You can be at the same line or you can rejoin this link again. So you can stay at the line or you can rejoin it again at 2:30 p.m. So now lunch break is declared. And regarding the attendance, many has asked a question how the attendance will be taken. So those who are attending through the online mode, since we are using Cisco WebEx, so attendance will be monitored by the software itself. And as we know, for the AICT programs, attendance is a mandatory requirement. So I request all the participants to attend all the sessions, because without 80% attendance, certificate cannot be generated. So I request all of you to attend the program and the every session, and the attendance will be recorded by the software itself. So there will be no any other feedback form or Google form like that. So as it is recorded itself, so no need to worry for the attendance. And now lunch break is there. We will meet again at 2:30 p.m. Thank you so much. Good afternoon, sir.
Yeah, good afternoon.
Yes, sir. A very warm good afternoon. Welcome to the post-lunch session. So for this session, we have K.A. Rajesh sir, Joint Director and Head of Central Institute of Petrochemicals Engineering and Technology, Kochi, and the Ministry of Chemicals and Fertilizers, Government of India. Sir is an MTech in Chemical Engineering, and Sir has a postgraduate diploma in plastic engineering also. His research area are biopolymers and composites, plastic recyclings, and he has expertise in teaching of plastic materials, plastic testing technologies, and plastic recyclings. Sir has attended and participated in different workshops, invited lectures, and he had many numbers of international and national publications. And as an investigator, he has performed and completed many research and development projects and expertise in technical education, technical consultancy. He had more than 20 years of experience. He had visited abroad for advanced training on testing equipments like Italy. And Sar had a versatile profile of working, just like he is associated with testing department and head consultancy services to industries and R&D projects. And we are fortunate enough today that Sir has consented us to deliver a lecture on plastic waste management. Over to you, sir. We welcome you, sir.
Yeah, very good afternoon to one and all present here. It is a pleasure for me to join for this program. I thank you for a nice introduction, Dr. Jutika. I thank Dr. Sanjay Chaudhary sir from CIPET Guwahati and also the team CIPET Guwahati for providing me the opportunity for handling the session today. So I will be just sharing the screen, and since it is post-lunch session, so all of you should bear with me. I will make my presentation as interesting as possible. So anyway, if you want that I need to be repeated, you can just raise a hand. And regarding discussions, all we can have question answer session after the session, the theory session. In some of the I was told that similar kind of program was organized last month also. So there are 100 similar session. So any participants of that program, means most of the similar slides are be there, but there are some different slides also has been included for this presentation, which will be sharing to all of you. So once again, I thank you and for the presentation, sharing the presentation. Yeah, thank you. So whether my screen is visible to all?
Yes, sir.
Sir, it is visible,
Yeah,
sir.
and voice is audible now? Yeah. So I'll be handling today the session on plastic waste management waste to wealth. So the content is regarding the collection and segregation of the waste, recycling of plastics, is machinery use, applications of recyclates. So these are the contents which will be dealing today in this session. So from morning to evening, we use plastics in different form, starting from the toothbrush, laminate tube, toothbrush tube, water tank, plumbing line pipes, bucket mug, soap case, comb, mirror cover, clothes, kitchen cover, buttons, shoes, kitchenwares, lunch box, water bottles, school bags, the boxes, transportation vehicles, office equipments, the computers and industrial equipments, dinnerwares, chair, TV, beds, blankets. Till we go to the bed, till the time we use a lot of articles with plastics. So you can see that in number of components has been which we are utilizing in daily life are made up with plastics. So the consumption of plastics, India's per capita consumption is around 11 kgs, and the growth rate of the industry is around 12 to 15% per annum, and world average consumption per capita consumption is 30 kgs. So India's the plastic industry is growing, and the consumption also is increasing. The consumption of the plastics is increasing as our daily needs are increasing, and also due to the increase in demand, the industrial sector. You may know that when in India there were no PPE kit producer during COVID. But we could find that when the COVID-19 has come, the pandemic has come, the plastics, the material has come into picture in the form of PPE kit and saved the life. So there are in India now there are many manufacturers of PPE kits, and the non-wovens are being used for as a PPE kits, and the plastics it has protected the life. So the word plastic, it has derived from the Greek word that is plastikos, which means that it is capable of being shaped and molded. So the plastics, generally it is shaped and molded under the particular temperature, particular conditions of temperature as well as pressure. So that is the meaning of plastics. So plastics are the synthetic or semi-synthetic polymerized material which can be molded into a permanent object having the property of plasticity. The properties of plastics, which might have discussed in the last session detail, just I am going through the major aspects of the plastics. It is resistant to heat and temperature, durable, insulator, inexpensive, and easy to produce. The polymers, plastics come from a family which is called as polymers. The word poly means many, mers, that is mers means units. So many units repeatedly combine together to form the polymers. So in polyethylene, the ethylene, it repeats number of times to form polyethylene. So there are major divisions, the thermoplastics and thermosets. So thermoplastics can be repeatedly heated, processed, and converted into product. So generally what we use daily, around 90% of the articles, it belong to thermoplastics. The thermoplastics are recyclable in nature. So the material of our topic that discussed more will be of thermoplastics in nature. There are thermosets. The thermosets, it means that it undergoes a setting, that is cross-linking reaction due to temperature. So it is thermosets. So generally it cannot be remelted and converted into a product again. So generally the recycling is very, very difficult in the form of for the thermosets. The thermoplastic, basically the thermoplastic which is used in commodity applications are polyethylene, polypropylene, PVC, polystyrene, styrene acrylonitrile, PMMA, etc. Out of that, the largest consumed plastic is polyethylene, and then PVC, then polypropylene. Engineering plastics. In engineering plastics, we have got wide variety of plastics like PET, nylon, ABS, polycarbonate, etc. The thermosetting plastic, for thermosetting plastic is basically phenol formaldehyde, urea formaldehyde, melamine formaldehyde, unsaturated polyesters, and epoxies. So these are the plastics which are used for the construction of different boats, ships, transportation vehicles, and also in the aerospace. So when we compare the mechanical properties of plastics with other materials like steel, brass, and aluminum or wood, we can find that you can see that the plastics are a suitable candidate for durable or semi-durable applications. So the materials such as ABS, it possesses a strength of ultimate tensile strength of 28 to 55. Nylon, with reinforcement, we can achieve up to 210 tensile strength. So this is sufficient. It is sufficient for generally the commodity as well as engineering applications. So that's why the plastics are the better candidates for commodity and automobile applications and widely being used because of its mechanical property. And it is having also not only the strength, its density also is very less. So we can achieve. So it is having a high specific strength. So that's why it is called as the plastics of the material which is having a high specific strength. So it is widely used in different fields such as packaging. The major use of plastic goes in packaging and further in building and construction to a percentage of 23%, and then goes in furniture or houseware 8%, electrical and electronics 8%, transport around 8%, agriculture around 7%. So these are the major applications of plastics. So plastics are being used in different fields, and the major applications of plastics, it is in packaging sector. So the journey of plastics started from non-structural applications, and then the plastics have been modified with certain fillers and then certain additives and fibers. So which due to which it has been used, its consumption has been used, has been raised from non-structural application to semi-structural application and further to the structural application. So that's why, so the cars like nowadays the electric, it's age of electric cars, hybrid cars are coming up. So where the fuel consumption is should be very less, and it should be energy efficient in nature. So in that, the structural components will be the polymer plastic composites, based on plastic composite, right? Come in combination with reinforcement of the fibers. So the journey, it it is increasing from, the consumption has been increasing, and which also accounts for the less carbon dioxide emission. So the use of plastics in terms of basically in general in automobile application, it helps to reduce the carbon dioxide emission in nature. So other areas of growth prospects of plastics are, apart from transportation, electronics, building, leisure and tourism, packaging, textiles, etc. So these are the areas where the consumption of the plastics are still going to increase in India. As we have already discussed that world's average consumption is around 30 kg, and we are still around 11 to 13 kg. So there is a huge gap. So there are plastics will penetrate into different sectors in uh, uh, for producing of different components, especially in electronics, building, etc. So now the imports has been stopped, especially for toys and all, and the major electronic goods are also now it is imports are being restricted. So there is a growth, huge growth prospect for the electronics and other construction areas. And also the plastics are functional plastics are also used for making the conducting polymers, light emitting polymers. These are all used for mobile applications and smart TV applications, etc., which are all coming up. So as per the development and as per our lifestyle is prospering, so the improvement of plastics, improvement of polymeric materials also happens, and the properties are being improved, and it is being designed for new and new products. And this is just a snapshot. The plastics are being used in automobile. More than 500 components are being used in cars, small and big. In terms of the bumpers, terms of grills, radiator grills, in terms of mirror back cover, etc. So when we see the plastic consumption sector-wise, as earlier told, the packaging it is having major consumption. And when we talk about today's topic, that is plastic waste, we can see that the plastic waste generated in India mostly into around into packaging and retail sector, and around 8% of the packaging films are in comes in that is MLPs are coming in India, and 8% it is in garbage bags, 10% PET bottles, 12% around bottle caps and lids, chips and confectionery packets around 19%, 7% in retail bags, 7% the straws, 5% the food bags, and 4% the cling wrap. So these are all being recycled in India. The items are being collected and recycled in India. So plastic waste, when we see, these are the application wise, and when we see this slide is generally focused on for the single-use plastics. And when we see this resin type, what is the plastic waste generation? We can see that major share it is for the polyethylene. The LDPE and LLDPE, it is around 28%, 28.4%. SDP is around 15.4%, and then polypropylene is around 15.9%, and then PVC is around 12.1%. So these are the major materials being recycled, and also the PET, it is somewhere around 4.2%. So this is the resin-wise plastic waste details. So which and based on this data only, this the largest consumed waste, largest waste, largest generated waste is being consumed for recycling. Recycling. So most of recycling material is polyethylene in nature. So when we go for plastic waste management, so we can the statistics tells that around 26,000 ton is the plastic wastage it is generated in India. So every year India produces around 9.25 million tons of plastic waste. So if you when you compare with the Taj Mahal, it is around 771 times. When we are comparing with the Qutub Minar, around it is around 14 lakhs times, and Charminar it is around 660 times. So that's what the volume of plastic waste which is being utilized or being generated in India. So there is a scope of plastic recycling market. So out of this, we want to like to mention that out of the plastic waste generated in India, around 60% are being recycled, and only 40% it is remain uncollected, and it is which is actually causing the littering, contribute to the littering. The plastic recycling market in India, hence it is estimated to grow a rate of 6.5% to achieve a market size of 53.72 billion US dollars by end of 2023. So that's what is the estimation, and hence there is a huge scope for plastic recycling in India. So when we go for the plastic recycling, so what is the interest? What is the product which can be collected and converted for the recycled products? So generally, it is based on the duration, based on lifespan. It is short life and long life plastic articles are available. The short life plastic articles like carry bags, multi-layer films, woven sacks, bottles, disposable cups, biomedical bags, plastic products, other plastic products which is used for medical applications such as syringes, etc. So these are all having the short life, and this is actually these are the material under our scope which generally undergoes a large volume of recycling. And there are rigid plastics, rigid durable plastic articles like chairs, crates, pipes, profiles, automobile components, household components, etc. So which is having long life and durability, and hence it undergoes less number of recycling. So for a recycling industry prospects, it needs to identify the source of the material based on its lifespan as short life products. So short life products are being recycled in a large volume. So when we compare the source of the plastic waste, It is accumulated at different sources, and out of the major source is the municipal solid waste. So the municipal solid waste, it contributes and for like packaging materials, consumer goods, etc. It is available in the large volumes, and hence this gives more volume of waste for the recycling industry point of view. And other sources of waste are agricultural sector, automobile sector, construction sector, industrial waste, plastic processing industries, polymer manufacturers, hospital and medical waste. In agriculture, the nursery bags, mulch film, irrigation pipes, etc. In automobile sector, bumpers, dashboards, etc. In construction sector, doors and window profiles, etc. Industrial waste is containers, drums, etc., especially for chemical packaging and all. The industrial waste. Plastic processing industries, its feed system, rejected products, the scrap which is generated in plastic processing industries. In polymer manufacturers, the off-grade products, that is when the grades are being changed. When material it is changing from one grade to another grade, the off-grade products are being generated, and this is also forms as a waste, and generally it is used in some proportion along with the virgin material for manufacturing of the components. The hospital and medical waste, that is disposable syringes, prosthetics, tubes and bottles, etc. So this is the flow diagram of the consumer waste, recycling of consumer waste. Consumer waste, basically it is household waste is the largest one, from where it is being collected through scrap dealers, and then the scrap dealers or it is being collected through rack pickers, basically rack pickers to scrap dealers, and then these scrap dealers gives to scrap wholesalers, and then scrap wholesalers it gives to recyclers. So based on collection and segregation, it gives to the recycling industry, where recycling in industry it is being sorted and cleaned, and then dried, and then it goes for the recycling into different products. So the generally apart from household waste, the hotel or hospital waste, street waste, dump and also which are being collected are then recycled into different products. So segregation of the plastic waste. So segregation should start from the source, so from where the plastic waste is being generated. Like we can come to know that the majorly this PET bottles, the drinking water bottles or soda, aerated beverages bottles, etc. So after being consumed, so this can be cleaned and kept. For that, it can be collected by a rack picker and it goes for recycling. Similarly, for the carry bags, the soft bags, soft plastic materials, and so these are all can be collected, and there are different 16 different groups which we can find basically the day-to-day used articles which are being disposed in large numbers are paper, cardboard, put together can be plugged in one group, PET and hard plastic separate group, soft plastic goes in separate groups, the coconut shells, clothes, glass, sharp objects, metals, ceramics, e-waste, tubeless and CFLs, batteries, non-recyclable materials, infectious biomedical waste, medicines, etc. So these are the daily used articles which we can based on the recycling we can categorize into different this thing, or it can be classified into plastics, metals, glass, etc. So in plastics, it is soft plastic and hard plastic it goes into. And there is a worldwide convention for sorting out based on its resin ID. So there is a triangle center symbol. It signifies that the material is recyclable in nature. So this triangle symbol, it can be seen in not only in plastic articles, whichever the material which can be recycled, it is identified with a triangle symbol, and inside the triangle symbol the number denotes which plastic it is made up of. So 1 indicates PET, 2 indicates STP, 3 indicates PVC. So there are in social media there was a misconception that 1 means it can be used only one time and then you should go for recycling. 2 means 2 times only it can be used and then it should be recycled, like that. So it is nothing like that. It's a worldwide convention, and the number which is inside the triangle, it denotes the resin, the which plastic resin it is. So these are being generally printed over the plastic articles so that it is easy for identifying the item which resin it is made up of, and so that it can be collected and recycled. So PET is there. It is generally used for making the drinking water bottles and aerated beverages. So it can be recycled into fibers, polyester fibers, thermoformed sheets, strapping, etc. STP, the high density polyethylene. 2 signifies for HDPE, that is high density polyethylene. High density polyethylenes are generally rigid containers, and it can be also be recycled into various bags, recycling bins, agriculture pipes, etc. PVC. The PVC 3 denotes for PVC, polyvinyl chloride. Polyvinyl chloride can be recycled into low-cost pipings and fencing, floor mat, etc. 4 denotes for LDP, that is low density polyethylene. Low density polyethylene can be recycled into become plastic bags, various containers, dispensing bottles, etc. Various other molded articles can be made from LDP. 5 denotes for PP, that is polypropylene. The polypropylene are recycled into different auto parts and hangers, etc. The polypropylene is the material which is generally used for furniture applications like tables, chairs, tables, chairs, etc. And once it can be recycled, it can be recycled into ropes also. It can be recycled into strappings, different products. Polystyrene. The 6 denotes for polystyrene. Polystyrene, generally it is shown in can be seen in transparent articles, and polystyrene also is it is in the form of styrofoam, that is expanded polystyrene. Expanded polystyrene, so this can be recycled into different other articles like cafeteria trays, toys, cassettes, insulation board, etc. It is also generally used for making some solutions and emulsions, paints, varnishes, etc. And 7 denotes for others. If it is a multi-layer plastics, it comes in 7. Whether it is nylon, it comes in 7. It is a biodegradable plastics, it comes under 7, the category of 7s. Acrylics comes under 7. So other engineering plastics also, PPS, PPO, etc. Everything comes under the resin code under the number 7. So these are all recyclable in nature. So based on the resin identification, there are 7 different of classifications, and based on this classification, it can be identified, and it is easy for segregation, and it can be recycled into different products. So the PET, the pictorial presentation of each resin I am showing in the coming slides. For PET, it is a transparent bottles such as bottles for food containers, etc. A water bottle, oil containers, etc. So it comes under PET, and generally it is notified as triangle with number 1. And for HDP, the rigid containers, rigid opaque containers and cans, jerry cans, oil containers, small oil containers, etc. with rigidity. It is HDP, high density polyethylene. So this comes under the category of 2, and HDP, it is HDP generally also used for making the crates. So the crates are under the category of 2. There are bags which comes for packing of rices and all, rice, wheat, etc. So sugar, etc. It comes with a very hazy appearance. It is the material is called as HMHDP, high molecular weight HDP, HMHDP. It can carry more weight than the LDPE material. So HMHDP. So these also can undergo the recycling. So polyethylene, the paint containers is HDPE polyethylene. HDPE pipes are there, which is used for irrigation purposes. Then PVC, the profiles, door window profiles comes in PVC. Pipes and fittings comes in PVC. So these all can be recycled, and rigid PVC pipes, hose pipes, the flexible hose pipes, the floor tiles, the blood bags, transfusion set. So vacuum forming. So this is the area which is now also it is developing. The electronic goods are being packed with vacuum packing with the thermoformed products with PVCs. Then LDP, 4 denotes for LDP. LDP, the milk packets, carry bags, the greenhouse films comes under LDP, and the tank, milk container, etc. comes under LDP. LDP. The polypropylene. Polypropylene is, as I told, it is generally used for making furnitures and all, and also the woven sacks are made from polypropylene. Then the single-use articles like cup, cutlery, spoon, cutlery, etc. It comes under this. Then the transparent glasses comes from polypropylene. Different containers, food containers, which is in contact with the microwave oven, microwave ovenable containers, and also the hot containers or hot pack containers, etc. comes in polypropylene in nature, transparent containers, and also the parcel containers comes in polypropylene, the furniture, and these garments, the transparent film, it comes in polypropylene. So these polystyrene, disposable cups made up with polystyrene, the styrofoam also. Multi-layered plastic, under the 7 category of 7, you can see number of products which comes in with a combination of different polymers like PP and PET, PE and PET, etc. For getting better permeability properties. So for that, multi-layered plastics are being used. So this comes under 7. So these articles then need to be segregated, and based on its appearance and its visually, it can be separated like this. So this is the first step for the plastic recycling. So it is segregation. It is done at source. So this is the segregation facility where the laborers are employed, and the waste is being segregated into different categories. And there are, apart from the manual separation system, there are sensor-based separation system also, like for the automation for handling a huge volume of plastic waste. Color recognition system is there. Then NIR is each polymeric material is having a particular infrastructure. IR, infrared spectrum in that NIR. In the NIR region, based on the functional groups, each like for each polymer, it's based on its functional group and its molecular structure. Is having infrared spectrum like our fingerprints. So these based on the how fingerprints are being identified, like that the polymers also can be identified with the spectrum based on its spectrum. And using NIR, it is a convenient technique to recognize the identify the material. So NIR also being used. X-ray transmission technology also being used for based on density. Based on density, it can be separated. So X-ray fluorescent technology is being used for with atomic characteristics. Then Raman spectroscopy is there to identify the plastic components. It is being used as an alternative technology to NIR. It is cheaper. Raman spectroscopy is cheaper to that of NIR. Then electromagnetic separators are there. The separation happens through conductivity and magnetic permeability. Then which is spectrometer. So these are the 7 different ways with which the plastic wastes are segregated based on its different aspects, and so that large volume of in the waste can be segregated. Color sorting. In color sorting, this is the mechanism through which this is scheme through which we can find out different with the camera. It can be sorted which is of a particular color, of a which is of a particular brand name can be collected separately, and which is of different color and different brand name can be collected separately. So it can be sorted out. Then infrared spectrometer, NIR is there. So based on NIR, the plastics can be, the materials can be identified based on its spectrum, and then it can be sorted out. The NIR separator in through X-ray transmission also we can identify with the different atomic atoms, and it can be separated. And the metal, as I told, different fillers are being added with the plastics for modifying its properties. So these fillers also, based on the fillers also, it can be sorted out. And Raman spectroscopy, this is the Raman plastic sorter. It is similar to that of NIR, and the plastics can be segregated into different categories. So this is the resource recovery center where you can see that there are the different waste are being collected and segregated, and then it is handled with different machinery like scrap grinder, baling machine, etc. So before going that, I just go through some of the videos that can realize what is the process. So I hope the video is visible to you. This is the video for grinding operation. So this is the audio for this is a video for the segregation of the plastic and this grinding, how the waste are being grinded and then it's sorted out. So it is made into flakes. The product are being made into flakes. So next we will go for different steps in recycling. So in basically the plastic recycling, the major thing is the mechanical recycling, and the steps in mechanical recyclings are the sorting, cleaning, then agglomeration, extrusion, and then storage and marketing. So first one, as I told, so these wastes are being collected and grouped together so that now the waste which is collected, it has to reach the plastic recycling industry. So the reduction of volume is important. It is compacted. So the machinery used is called as baling machinery. So with the use of baling machinery, the plastic, the collected waste can be compressed together into the form of the bale, and can be transported very easily to the recycling industry. So the volume reduction can happen with the baling process, so that this can be transported in large quantity, because as you know all know that the plastic is having very less weight, but it occupies a huge volume. So the handling of plastic waste is a difficult process, as the weight is very less and the volume is more. So handling huge volume, for that actually there are mechanisms are required, like baling and then shredding. In shredding process, the plastics or the articles are grinded, and then it is made into the form of flakes, and then after the flakes, then it is being transported, or it can undergo extrusion process. So the scrap grinder is having different types of blades. This is a typical scrap grinder, where the plastic materials are treated and then it is grinded, and to get flakes, we will be getting in flake form. As we have already seen that scrap grinder, then there are disc pulverizers are there, which will convert the plastic articles into small powders, especially for PVC materials and LLDP materials, like water tank and all. Once it is pulverized, you will be getting in the powder form, and then it can be further, it can be processed into different other articles. This is the agglomerator. It is used for the recycling of the plastic film, flexible film applications. The flexible film sheets, etc. Once it is collected, it needs to be densified, so that you will be it is easy for further extrusion. So the agglomerator is being used. Then goes for the extrusion process. The extruder is a major one, where the plastic granules are fed in the feeder, in the hopper, and then it is transported through a metal barrel, where the screw also is there. The barrel is used for heating, and there is a screw which will be rotating constantly. It conveys the material from the feed to the melting zone, where it melts and it forms the strands. It is converted into strand form, and then this strands is then further it is going to the this is the extruder material. You can see extruder machine. You can see that this is the hopper, and then barrel. Through the barrel, it extrudes, and then it goes through cooling trough, and then it goes for pelletizer. It's a pelletizer, where these strands are being cut in uniform sizes, and we will be getting the uniform pelletized material, which will be ready, which can be readily used for next process like injection molding, blow molding, etc., or film also. The mechanical recycling of plastic undergoes different stages, which some of that we already discussed, like inspection, chopping, washing, flotation tank. In flotation tank, we can actually separate the material based on the density. The plastic which is having a density of less than 1, it floats in water. Polyethylene, polypropylene have density less than 1, and others are having density greater than 1. So the polyethylene polypropylene material always floats in water unless it is compounded. So it floats in water and it can be easily separated. Other plastic, it settles down, and then after flotation it is then dried, and after drying is melted and filtered through the extruder. So the contaminations are avoided, and then we'll be getting pure melted, and then it is pelletized, and this pelletized materials, and then it will be going for next process. So this is the whole scheme of plastic recycling unit. And before going that, I will be going for one more video. You can see this is a extruder, recycling extruder. Here these flakes. Flakes are feeded grinded material, and it is molten, and it goes for pelletization. It goes for a standing process. This one, if you are attaching a die, you can get rectangular bars. And these rectangular bars can be further used for making the furniture. So this is the so go to next slide. So the generally when we see the plastic articles, other than plastic carry bags, we can see that the more generated waste is the PET bottles. So PET bottles are then collected, and then it is 100% it is recycled into flakes and fibers. So the extrusion with the extrusion and spinning technology. So the PET is baled. It is baled, and then from the collecting from the source, it is baled, and then it goes to the factory for converting it into fibers. So apart from the PET bottles to bottle to fiber technology is also used for producing of fibers, staple fibers, which is generally used for making the cushions, pillows, etc. and it is also used for industrial fibers for belting, webbing, pads, filters, etc. So the PET bottles is converted into fibers for different applications. Then recycled PET bottles, it is converted into sheets, and this sheets can be generally used for carrying of eggs, fruits, etc. Nowadays, in supermarkets, you can get even the chopped vegetables. So these are all can be packed with the recycled PET bottle made boxes. It's made from recycled PET bottles, transparent bottles, and then PET bottles are also can be converted into bowls, can be converted into different gift article forms, etc. Now let me go. I will go for and go to play one video which shows the different stages of PET recycling. Plastic bottles are being collected and then it is being shredded into flakes. So it is being shipped into different places. The scrap grinder, you can see that it is converted into flakes, and these flakes are then being washed in order to remove the contaminations and then being dried. The homogenizer, so the color also is added. So in order to make it isn't a uniform color. And this is the melt extrusion happening. The extruder, the screw, it rotates and plastics are being melted. And this melted plastic, it comes into strand form. The strands are then winded out as a fiber bobbins. And these fibers are binded together to form a continuous fabric. goes for a weaving process. So PET is generally polyester, so it is the PET bottles, the waste. It is value added and to make the jerseys and all. So last World Cup, the Indian cricket team has wear the jerseys which was made from recycled PET bottles. So this waste, when it turns into wealth. Let me share my presentation. There are in India also, in Gujarat, Tamil Nadu, that regions we have similar kind of industries which convert. Hope the screen is visible. The screen is visible,
Yes,
no?
sir.
Yeah. And other than PET, the other plastics like ABS, polypropylene, etc., is also recycled to make different articles. Some of the articles I have shown in this figure, like luggages, small stools, crates, different carrying packets, then dolls which is made from recycled plastic after and then it is being decorated, and coasters, the tea coasters, and different low cost domestic articles like bucket, mug, flower pots, small crates, baskets, so etc. can be made with recycled plastics. And the recycled plastics are also used for making the sutlis and strappings. So generally the sutlis, it comes with recycled plastics, and the box strapping, the cartons are packed and then sealed with the strapping. The box strapping is made with the plastics. So there are different products. The SDB woven sacks can be converted into pods. Multi-layer film can be converted into other different park benches, etc. The polypropylene can be further turned into box strapping. PVC items can be turned into footwear. So this is the statistics regarding the various plastics. The waste material which is being collected and then recycled. The polyethylene is around 300 kilotons, polypropylene around 240 kilotons, PET around 110 kilotons, PVC flexible around 180, rigid PVC around 160 kilotons. This is the material, the quantity of the material which is being collected and recycled in India. And as you all know that India is the country, it's the number one country in recycling. We recycle around 60%, where the world average is somewhere around the 30 to 15% only. So India, because of its cheap labor and also availability of areas and availability of machinery, here we do more recycling than any other country in the world. And apart from mechanical recycling, these are the so far we were discussing about the mechanical recycling, and the plastic waste can also be converted into different other process other than mechanical recycling. It can be used for road construction. It can be used for generation of the converting into oil, and it can be used for also be co-processed in cement plant, etc. So the plastics, it is used as a binder for road construction. Generally, this is the flow chart of the plastic coated bitumen road. This is a very success in India, and it is also done as per the regulations of PWD and NHAI, National Highway Authority of India. They have already approved this process for making the for using the 10% of the plastic waste for bitumen road. So what does the process is that here the advantage is that you need not segregate the material. Without segregation, only the contamination need to be removed. The contamination need to be removed. The cleaning need to be done. No need to segregate. Just grind it and making into flakes. The desired shape is around, desired size is around 2 to 4 mm. We need to make it into flakes, and then these flakes are then applied over the water over the heated stone. When the stone aggregates are heated around 150°, so then the plastic is applied over that, so that the stone will be coated with a thin film of plastic. So the stone, once it is coated, the coating becomes very strong as the plastic it adheres to the stone, and then further it is mixed with hot bitumen at a temperature of 150°, 150 to 163°, and then the road laying happens. So the main thing is that the plastic shredding waste need to be applied over the stone only, so that the stone coating is there. And then further with the plastic coated stone, when it is being heated with when it is being applied with bitumen in hot form, it undergoes the stone plus the bitumen will have a very good adhesion, so that the life of the road will be increased further, and there will not be there is a less chance of a pothole formation. The stripping and road hole formation is very less, because there is a hydrophobic coating of the polymer which is over the aggregate, and hence it prevents the water being staying there for a long time. So the plastic, another application is that plastic. Yeah, no, actually, I want to mention one more point is that for bitumen coated roads, around 10% of the polymer plastic waste can be used. So it is estimated that for 1 kilometer, for the construction of 1 kilometer road, requires around 1 ton of plastic waste. So if now the lot of highways and everything is coming, so if we use the plastic waste in a very particular way in all these things, so then I hope that there will be scarcity for the waste also. So we will not be able to see a single plastic waste which is being littered. Is all it will go in for the construction of the road, and it does not have any means like no other processes involved. plastic waste into fuel oil. So the plastic waste, it as we all know that plastics come from petroleum. It's a petroleum based product. So it once it is pyrolyzed under a inert atmosphere in presence of catalyst, is it undergoes the molecular breakdown and then it forms the oil. So generally the video that is diesel fraction and furnace oils are generated out of it, and it can be efficiently used as a fuel, especially for running the generators, and all diesel can be generated. And there are petrol fractions also comes, but as per the efficiency, it gives more efficiency for furnace oil and then for diesel. Then similar that commercial plants are also available in different parts of the world. Plastic waste also is used for fuel for co-processing in cement kiln. So it is having very high energy value than any other waste. The plastic can be used due to its energy efficiency. It can be used for generating the power, and the plastics are being used for as a source of energy for in the cement kilns. And it is also can be used for making the bricks, cement bricks, and for pathway blocks, etc. Plastic waste can also be used for making the bags. Creativity by binding everything together and to form a shape with the frames. It can be converted into lammy bags. And another item which is being manufactured out of plastic waste is the wood plastic composite, where the plastic flakes are binded with the wood particles, wood converted into small particles, and with the compatibilizer, the plastics is added with the plastics, and then it forms the wood plastic composite. And it's a good substitute for making the particle boards, different other boards and sheets, etc. You can see this is the PVC. Generally, PVC materials are being used, and then the wood pellets. So put together, we will get planks. So it can be used for different functional products for making the floor tiles. Can be made for making the lumbers, making the doors, making the pallets. So this wood plastic composite can be used. It can be beautifully used for different construction applications, energy efficient applications, etc. Because it is plastics are generally insulating in nature, and hence by using this material in construction, like false ceiling, by internal partition, and this for different insulation purposes, it will definitely conserve the energy. For it, it also it will also reduce the AC consumption, etc. So hence it is used as a green material for the construction purposes. Conclusion: plastic-based recycling will facilitate the clean environment. It will give the employment opportunities, economical products, business opportunities, etc. So here we have seen how the plastic waste can be recycled into this thing, and there are upcycling ideas also, because with one's creativity, we can upcycle the plastic after use into different articles by changing its or by altering its shapes. There are flower pots or vertical garden. The concept of vertical garden, where the gardens are arranged in vertical, and there is plastic waste is generally it is used as a flower pot for for this nursery purposes. Another picture where you can see that the small plants are growing in the cut PET bottles. So this is used in when decorating on railway station. And the plastic waste. So if you are just altering its shape and size by cutting and this finishing operation, it can be used for making different stands. Cans can be made into stands and stands or small bags. Can be used as a toothbrush holder. It can be made as a pen holder. It can be used for keeping the different pens, the different small students. You see, it can be used as a for keeping the the other items for makeups and your makeup and toothbrush holder, etc. And it can be used as a magazine holder. Cans can be converted into magazine holder. It can be used for keeping the shoes, preserve the shoes. Can be used for say coin purse. Can be decorative containers. Can be kept for say lampshades, jewelry stamps, bird feeders, and some of our students they have done work for collecting the waste and converting it to different articles. Some of the articles you can see in this slide. This is a bus stand which is made up of PET bottles, and this is another cottage. It is made up with PET bottles, and these PET bottles by filling the sand and pasting with plastering with cement, it can be converted into economic cheap cottages that you see. So this is also being used. It is also used for making the boats. This is the Christmas tree out of PET bottles. The PET bottles, you can see the small. These PET bottles are colored in green, and then it is made for making the Christmas trees. Can be used for making the different jewelries. So with recycling and upcycling, let us we can convert all plastic waste into value-added different articles. Let us hope for a greener. Thank you very much for attending the session patiently. Thank you all delegates. We can move to question answer session.
Session is now open for interaction. If participant wants to interact with sir, please online participants, please raise your hand. Sir, there is a question from.
Good afternoon, sir.
Yeah.
Sir,
Yeah, please
good
continue.
afternoon, sir. Sir, I am from CIPET, CSTS-GUWAHATI, and I am a fourth semester of the Department Diploma in Plastic Technology. Sir,
Okay.
first of all, sir, I'd like to thank you, sir, as your presentation was quite informative for me. Sir,
Okay.
as you were talking about, sir, plastic waste management. So, sir,
Yeah.
you have mentioned about those eco bricks also.
Yeah.
Sir, my question is that, sir, my question is that, sir, are eco bricks is a safe way to end the non-recyclable plastics?
Yeah. Now there are technologies available which convert the plastic waste into the bricks, and also it is being used in different part of our country. Yeah.
Sir, you are not audible, sir.
Uh, Regarding the eco bricks, no. Hello, am I audible? Hello, am I audible?
Yes, sir.
Yeah, regarding the bricks, plastics, generally it is these wastes are collected and then it is being compounded with fillers and then the use stabilizers, and then it is being converted into bricks. And it generally the compound also contains flame retardant. And it is widely used now in different parts of the country. It's in practice. Any other? I hope your question is being answered.
Yes, yes, sir. Thank you, sir. Yes, sir. Thank you.
So
Any
there
other
is
question,
another
please?
question.
Yeah.
What about pollution using plastic bottles for making cottage and boat, etc.? Agnishwar Giri Goswami had a question. What about pollution using plastic bottles for making cottage and boat, etc.?
What is the I didn't understand what is the pollution?
Using plastic bottles for
Uh,
making cottage and boat, etc. So at the chat box there is a question from.
yeah, that is plastic when plastic bottles when being used for boats.
Yes.
Yeah, it can be used. Yeah, can be combined. These plastic bottles can be combined together, and you can form the shape of the bottles. You can form the shape of the boat, and it can be used because it floats in water. But it is of limited usage. It can be used wherever there are small islands are there. It can be effectively used for transportation purpose, and it is not a substitute for the long duration one. But it can be used. Can be it is a durable one, and it can be utilized for especially transportation. Otherwise, see some of the islands where the people they want to travel from one place to another through water bodies. So they need to wait a long time for the passenger boat. Here, that will be this will be a smarter solution to some extent.
Thank you, sir. There is another question
Yeah.
from Ujjwala. She has asked, she wanted to know if there is some commercial plan for conversion of waste plastics to fuel oil in India.
Yes. There are energy plants are there in Maharashtra and Tamil Nadu. The plants are operated. It is in operating condition. Plastics to fuel and then fuel to energy.
There is no thing from the participants to know from sir. We would like to thank you, sir, for this valuable and informative session focusing on collection, segregation, and waste management, consumption of plastics, mechanical properties of various plastics, development of functional polymers, plastic product classification, types and source of plastic waste, recycling, steps in mechanical recycling, resource recovery centers, then Indian experience of value addition, and all the factors which are associated and with the recycling. So we are very much thankful to Sir for spending his valuable times and offering us such an informative session. Thank you so much, sir.
Okay, I thank team CIPET Guwahati for giving me the opportunity for presenting, and I thank each and every delegate who has patiently attended my session, and also they also to have a nice interaction. Very nice questions we got. So thank you, and to all the best. Thank you once again.
Thank you, sir. On behalf of CIPET CSTS Guwahati, thank you, sir. Thank you so much. So, dear participants, for today the sessions are over, and tomorrow at 10 a.m. we will meet again. And I request all the participants to join by 9:55 a.m. morning positively. And tomorrow at 10 we have a session. The session will be delivered by Pradip Paik of Indian Institute of Technology BHU. And for attend, and this is for your information also that attendance is mandatory. And as we are using Cisco WebEx, Cisco will record the attendance. So I request all the participants to join all the session. And for today, the session is over. So tomorrow morning, with the same link, everyone can join. Thank you so much.